Most of the security issues are not found in production, but those are introduced in the much earlier phase of the code, the container, and the pipelines. Hi, and welcome to the one-shot masterclass of Trivy. In this video, you are going to learn everything that you require to know about Trivy. We are going to start from the very much scratch and we are going to end it till the production grade implementation. We are going to learn about Trivy. And Trivy is not just a vulnerability scanning tool, it is something which is capable of scanning your container, your Git repo, your files, your secrets, and it is even capable of generating software bill of materials. That is something which we call SBOM. Now, what actually SBOM is, those are something that we are going to cover in this specific video, right? In this video, we are going to cover what Trivy is, why we should consider Trivy in the very first place, right? How does Trivy works internally, how you can scan Docker images, how you can generate SBOM reports. You are even going to learn how you can fix the vulnerability the very right way. And also, apart from everything that we are going to learn, we are also going to automate the things so that you are not doing the repetitive task again and again. So at the end, this is not just a theoretical video. We are going to do practical hands-on so that we are aware how to fix buggy images, how to create the automation for the same. Everything that you required for Trivy will be present in this specific video. By the end of this video, I can promise you that you will have a clear idea how does Trivy works. Right? And at the end of this video, I will give you the resources that you require to get started with it. I will attach the GitHub repository, also the PPT that I will be using throughout the PPT. So let's get started with security. Now, what are the prerequisites of this specific series? So there is no such prerequisite. Even if you're a fresher, even if you are an experienced person, you will literally learn a lot from this specific video. Right? So yeah, grab your copy, open your terminal and start securing your Docker images with me. So let's get started with Trivy. Imagine you deploy your application and after 2 minutes, someone hacks it. Not because the code was bad, but the image that you used had a 4-year-old known vulnerability. Scary, isn't it? So here we are going to talk about a tool named Trivy that will help us to mitigate this issue. So Trivy is a tool that every DevOps engineer should know. It is a security scanning tool that helps us to scan the artifact. Now when I say artifact, I am talking about Docker images, and it helps us to know how many open vulnerabilities are there, right? So in this video, we are going to cover what actually Trivy is, why we should consider Trivy in the very first place. And after getting through this video, you will never deploy any image blindly. So yeah, let us understand what actually Trivy is and what powers does Trivy add into our plate. So yeah, let's get started with Trivy. Alright, so let us begin and understand what actually Trivy is. And here we are going to cover everything from the fundamentals to enterprise grading security scanning. Now, before even doing a deep dive, let us understand why, what and how we should deal with Trivy, because it is the very first step into the container security. Now, whenever we are learning any tool, we just have to be clear why we are learning that tool, what is that tool and how we should use it, right? So first, let us cover what is Trivy. So Trivy is an open source security scanner tool that is created by the company named Aqua Security. And what it does, basically it scans images, YAML file, clusters, file system, each and everything. It is very fast, simple and beginner friendly. All you have to do is just pass one command, for example, Trivy image followed by the image name, and it will literally print all the vulnerability that is associated with that library or that image. Okay. Now, why does Trivy exist? So Trivy, what it does, container images oftenly have outdated packages. Now there should be someone who is scanning them, right? Because if we are using outdated packages, meaning all the vulnerabilities that are present there will be existing in our system. In order to find those, we need a tool that will solve this purpose. And here, Trivy does the job. Security risk increases with microservices. If you are using multiple libraries, multiple binaries, that is Docker images, and it has open vulnerabilities, meaning you are introducing those bugs into your current code, right? In order to mitigate that, you need someone who will do the job, and here Trivy does the job. So we need someone who will do the job faster and in an automated manner. And here Trivy will do each and everything for us. And that's the reason here arises the term called DevSecOps. that introduces security into the DevOps domain. And here, Trivy is one of the DevSecOps tool. Now, when we are talking about scanning, here we are talking about CVE. Now, what actually CVE is? So basically, CVE stands for Common Vulnerability and Exposures. Like the name suggests, it is telling you all the common vulnerability that are been reported, and it is been stored somewhere, basically a common database from where it is fetching the data. Now, in order to understand CVE, let us take a very weak example of antivirus. Now, antivirus is again a pool of database of all the viruses, right? It takes the references from there and then it will tell you that, okay, it is affected with this virus. Likewise, CVEs are also maintained. CVEs are like maintained databases where all the information of the known vulnerability has been stored, and based on that, Trivy will show you the result. Now, each CVE has an ID, severity, description, and fix. Okay, it is used globally for vulnerability tracking. So, when a bug is been logged, it will generate one ID. It will give the severity. Now, what is severity? It can be high, medium, low, and extreme. Now, based on that, it will provide a description. What does that bug do, and where is the fix? Let's say you're using a Python library version 3.10, and the fix is present on version 11. That is how it will tell you that the fix is given in this version. So you just have to update the library, and that is how things work. It is used globally for vulnerability tracking, and here Tree pulls the data from trusted vulnerability databases. Now, what are those databases? We are going to cover in the coming video. But for now, just understand that there is a database where all the information is been stored, and it is pulling the data from there, and that database is being updated regularly. So if there is any new vulnerability, you will be up to date with the tool, right? Now, what does Trivy does in DevSecOps? Trivy helps with image scanning, repository scanning, file system scanning, Kubernetes security. It helps us with CI/CD integration and shift left security, right? So, in today's video, we understand the importance of Trivy that plays into a DevSecOps engineer's role. It helps us to identify the common known vulnerability and what are CVE. We understood those also. In the next video, let us see hands-on practical how to install Trivy and how do we scan an image and how does a Trivy reports look like. So when you actually perform it, you will get to know the look and feel how does Trivy looks like. So yeah, that was all, and I will see you in the next one. All right, welcome back. In the previous video, we learned what actually Trivy is. We got to know what actually Trivy does and why we should consider Trivy for scanning the images. This specific video, we are going to see how we do the installation. Okay, so without further ado, let's get started. So for that, we are going to start from very much scratch. I am going to create the AWS instance and I'm going to tell you how things are actually working. But before even we proceed, I have created one repository. In this repository, again, there will be multiple sub repositories. So the way we are going to learn it, all the things will be documented over here based on the sub repository. Now, if you go to the first directory, that is first Trivy installation, you'll find one readme.md file where all the information regarding whatever we are going to do in this session will be recorded. So here I have covered what actually Trivy is, the theory part, the bullet points for us to revise, and secondly, why it is used, and then whatever commands we are going to run today will be logged over here. Now, is this the correct way to learn? Well, definitely no, because this will be acting as a reference note for you. But whenever you are doing a fresh installation, I would recommend you to directly go to the website and directly take the packages from there. Now, why I am saying this is because there are multiple updates which are going within the company, and that is how they update their products. So whenever you want to do a fresh installation and whenever you want to take a long-term support application, directly go through the website and take the references from there instead of taking it from any repository. All right, yeah, even if you refer this repo, it will work because I just have created it. So it is based on the current date, it is latest, but I would recommend you to go to the website and do the installation. All right, so let's get started. Here I am in AWS account and here I'm going to create one instance. So it would be again a free tier account for us to do the work. So here I'll name the instance as Trivy and I'll select the base OS as Ubuntu again. And we'll keep everything as is. And for the key pair, I already created one key named Trivy key. And once everything is done, just click on launch instance. So it is straightforward. No need to change any of the configuration. We didn't even install anything. It is just a fresh instance with nothing configurations done at the beginning. Okay. I'll go to this ID and I'll just try to connect it with my console. I'll just copy the SSA and here I'll connect it directly to the install. All right, we are inside the instance and here you can see we are inside the terminal. Now let's get started with the installation. Now instead of going through these commands, I'll just show you what actually is present in the readme.md file. Here we are installing wget and gpu pg. So wget is used to install any packages from the internet and second nupg is used for verification of the keys. Now here we are downloading the key and adding it into the apt repository where it tells that it is a trusted file that you can install. And what apt is? apt is a package manager for Ubuntu. And once everything is done, we are going to update the system since we did the configuration change. And then finally, we are going to install Trivy and then we are going to run Trivy version to verify whether the application installs successfully or not. So you can directly copy and paste the commands from here, but I would recommend to follow the approach that I am telling you right now. Go to Google and search for Trivy installation on Ubuntu, and you'll find the first link that is trivy.dev. That is the actual website given by Trivy. And here you need to search for the operating system that you are using. If you are using Red Hat based system or CentOS, go for the installation methods given here. Now, since we are on Debian Ubuntu, so we need to copy this set of commands and the application will get installed. Now, if you are someone who is using Windows, then you can use one more package manager that is called Choco. So if you scroll down, there will be one package manager for Windows also. One second. And secondly, like you can also get an exe file equivalent. And if you are in macOS system, you can install it using Homebrew. So for Windows, let me just tell you Trivy installation on Windows. Okay. Again, it is the same website. Let us search for, yep. So here you can see, you'll find the Trivy zip file. If you go to the release page itself, it will give you the binaries. You just have to install this binary file and just run it as is, just like a normal application, and Trivy will get installed in your system. Now, since we are working on Linux based system, that is Ubuntu, we are going to follow the installation method given for Ubuntu. So let me go back here and copy the commands which are given for Debian Ubuntu. And whatever commands that are present over here, I already gave an explanation what each line means. Okay, and everything is logged in the repository itself. So this repository you can use for your learning purpose to understand what actually that command does. And for installation, go with the standard method, go through the website and refer the commands given in there. Yeah, once everything is done, paste the command and wait for some time. What it will do, it will install all the packages that are required for us to run the Trivy. Okay, now we learned that Trivy is used for multiple purpose. It is a security tool. So we would be scanning one of the images and we are going to see how does a Trivy reports look like. Okay, now there are multiple things Trivy offers, but one of the main thing that Trivy offers is security scanning. Now see what we did, we installed each and every package. Now it's time us to, if it is the time for us to verify whether the package actually got installed or not. So for that, I'll just write Trivy -- version, and you can see we have installed the Trivy version, Trivy here, and now it's time to validate the package. And how do we validate? So let's say you want to scan a particular image. Now I mentioned earlier that you can get vulnerabilities on official packages also. So let us demonstrate the same statement what I said in the previous video. So I'll go back here and here I'll search Docker Hub. I am not signed in right now. I am not logged in with my user. So I'll just search for the official image. So let's take Ubuntu for now. Now here you can see there is a logo that defines that it is an official Docker image. I'll go over here and the first thing that I'm going to do is I'll just check whether there are vulnerabilities in Ubuntu latest image or not. So for that I'll write Trivy image and name of the image. So Ubuntu latest. Okay. And if you see, it is updating the DB, it is downloading the vulnerability DB, it is downloading the artifact, and post that it is running the scan. Okay. Now, once the scan is done, it has actually printed the report, the security report that is required first to understand is there any vulnerability in this image or not. Now, here you can see it provided a tabular format for us, which will help us to understand what actually is the issue with Ubuntu latest image. Now, here it also provided us with a report summary, which mentions that the target image was Ubuntu latest and the version is 24.04. The type of the OS that we are using is Ubuntu. There are 11 vulnerabilities and no secret is passed. Okay. And if you scroll down, here you can see it has give you again a summary that how many low issues are there, how many medium issues are there, how many high and critical vulnerabilities are present. In total, it gave the count also, that is 11. Now, how? So basically, it will give you the output in two form, that is at OS level and at library level. So if you scan an application, it will give you the report for both OS and library. But since it is an operating system, it gave us the report for OS level. Now here you can see we have the CVE ID, severity, status, installed version and fixed version, and the title. Now, let's say I identified the issue. How do I mitigate it? So basically, right now you can see the installed version is 9.4-3 Ubuntu 6.1, and the fixed version will be provided in the coming fixes, right? And whatever issue is there, everything is logged out under this URL. So if you open this URL, all the information regarding that issue will be present over here. Now, what it says, so Aqua Vulnerability Database, I mentioned earlier, it is taking the reference from one database where all the information has been logged, and here all the information related to that vulnerability is been logged. Okay, here it is telling the CVSS score, that is 6.5, so meaning it is a medium level vulnerability, and what are the softwares which are affected, and is there any method to mitigate it, and what is the description. So every information regarding that vulnerability is been logged over here, and if there is any related pattern regarding the attacks, those are also logged over here. So that is the actual power of Trivy that helps us to identify the images. Let us take one more example from Ubuntu itself. I'll go back here and I'll go to tags, and let us scan the latest image that was pushed 3 hours ago. I'll click here and I'll copy the tag directly. So the name of the image would be Ubuntu rolling, and here I'll just type the command again. So let me just zoom in. So Trivy image, and this time we are scanning the image name Ubuntu rolling. Now again, what it is doing, it is scanning, it is pulling the data from database, it is scanning, and here you can see the reports shows that there are no vulnerability present, meaning the vulnerabilities which were present on latest are actually fixed over here. Okay, if I go back and show you the previous report, Ubuntu latest, the last time the version that we were using was 24.04, and it got fixed in 25.10. Okay, so that is the actual help that Trivy does. Now, in order to read this, you just have to go through this table. Okay, in this video, we learn how do we install Trivy and how do we run scans over few official images. Just before we close, just before we wrap up, let me scan one more private image that I have pushed in my local repository. So let me clear and let me search for my user. And here I'll take one of the image that I have that is present with me. So I'll scan GitHub profile summarizer, the project that we created in Jenkins in one shot. So it would be Trivy image and followed by the image. So again, it actually showed me the issue. There are 10 vulnerabilities and how many are present. So basically, see here, it is showing me the CVE value, the severity is medium, and here it is saying that issue is fixed and can be fixed. The installed version is 137.0R19 and it is fixed in 137.0R20. And if I want to know more about that issue, just click on this Aqua Security link and it will give me a detail about what actually that issue is, where actually is the weakness, what is the CVSS score, and what are the potential mitigation and the related attack patterns. And everything, whatever you want to know, is present under one hood. So it would be easier for me to identify what sort of vulnerabilities I am exposing along with my application. So yeah, that was all for today, and I hope you learned about the installation and how do you perform basic checks, how do you run a Trivy scan on a Docker image. Yeah, that was all, and I will see you in the next one. Thank you very much. Hey everyone, welcome back. This is one of the important video because here we are not only going to see what actually Trivy is, but we are going to see how does things are happening behind the scene. This is one of the important video. Why? Because we are going to see the internal architecture, how the scanning happens, on what factors CVSS scores are being generated, where does TV gets the data from, what is CVE, what is CVSS, all of these things we are going to cover in this video. And don't worry, I am going to make it very much beginner friendly so that even a beginner can understand what is actually happening when a Trivy scan is being done. This video we are going to do a deep dive on the architecture of Trivy. That is one of the important things. We are going to see application analyzer, we are going to see matching engine, we are going to see report formatter, we are going to see Trivy vulnerability database. Once the architecture is done, we are going to see the life cycle, how does this thing happens. We are going to understand where does Trivy database gets the data from, okay, and who is maintaining it, and on what factor CVSS score are been assigned. All of these things are clubbed in this video, so this video is literally an important video. So yeah, just wanted to tell you, just go through it, understand it. If you find any difficulty, just let me know in the comments. I will be there to help you out in it, right? So yeah, without further ado, let's get started with Trivy. Okay, so let us discuss about how does Trivy works internally. We are going to do a focused discussion on Trivy architecture because that is the main point of discussion in this video. We are going to understand how does the database flow and on what mechanism it is giving us the scoring, that is CVSS scoring. Right now you can see there is a mind map of complete thing that we are going to cover today, and this would be the complete mind map that we are going to proceed along with this video. The first and the main concept that we are going to discuss today is the architecture of Trivy. Now, Trivy contains four main components into the architecture, that is artifact analyzer, matching engine, Trivy vulnerability database, and a result formatter. Okay. Now, based on that, these things are working. And post that, we are going to understand from which sources it is getting the data from. Okay. What are GitHub developer advisories? Okay. And how does image scanning is being done, and what is the life cycle of Trivy when it scans an image. Those are all the things that we are going to cover today. So let's not rush. Let us first understand. Let us see the high level architecture, and it consists of four major components, that is artifact analyzer, a Trivy vulnerability database, matching engine, and report formatter. Here I will be taking few examples that will help you to understand what actually is the purpose of each component. Okay. Here, this visualization just gave us a clarity, an idea how does a Trivy scan works. So let us first understand. Now here we have a container image or artifact. So whenever I am talking about artifact, I am talking about Docker image. Okay. And in the coming videos, I am actually going to show you how you can generate a report, how you can resolve those vulnerabilities. All the things will be covered, right? But for now, let us first understand the architecture. Okay. So here let us consider that this blue box is a Docker image. Now, what artifact analyzer does it? It will just open a briefcase, just like when you go to an airport, you just put your briefcase, they scan everything. In the same way, artifact analyzer is a component in Trivy architecture that actually scans your entire Docker image. It will further classify it into two packages. First is it will classify the vulnerability based on operating system level, and then it will sort it out based on the package management level. If you are using Python, then it will sort down all the libraries and dependency based and related to Python. It can be pip, it can be npm. Now based on your image, it will show you the differentiator. Now, Okay, the first thing was to analyze. It analyzed the operating system, whether it is Debian, whether it is Red Hat, whether it is CentOS, and it also analyzed that, okay, what is the package? It is PIP or NPM. So that analysis is done. Now what next? The image further goes to Trivy vulnerability database and it again does an scanning. Now, what it does, it will again run a scan against the analyzed artifacts and then it will show you what sort of vulnerability are present. Now, where the data is coming from, there are multiple sources that we are going to cover in this segment. But for now, just consider that it is a rule book where all the criminal records are been logged. Okay, so here it will just check what sort of vulnerability is present, what is the CVE ID. Okay, now it will further push it to matching engine. What matching engine does, basically whatever things are been identified by Trivy vulnerability database, it will further match it against the uh, artifact that we have generated and the artifact that we are scanning. Post that, once everything is done, it will club it to a single place and it will pass it down to report formatter where it will generate a report for us. Now it can print a beautiful table over our console. It can generate an HTML document. It can generate an PDF. Now, based on our requirement, it will generate the report. And then finally, we are able to see the beautiful report over the console. That is the high level architecture of Trivy. Now, let us cover the first important component, that is artifact analyzer. Okay. Now, what analyzer does, basically, as I mentioned, it's just like opening a suitcase that lists down everything inside the box. What it extracts, basically, it reads the operating system. It classifies whether it is Ubuntu, whether it is Alpine, whether it is CentOS, whether it is Red Hat, and then it is extracting the packages. It detects the packages, whether which packages are we using, and also detects which dependencies we are using. Now, which manager are we using? Those all things is being analyzed by artifact analyzer. So if you want to visualize it, you can just imagine a suitcase. Now here the suitcase is a Docker image that we are talking about. Now what did this analyzer did? It basically it ran a check. It identified which operating system it is using. What sort of libraries and dependencies are there? Is there any config file present? Is there any secret present? What sort of application binaries and packages we are using? All the thing is been analyzed by artifact analyzer. I hope you got a rough idea what does artifact analyzer does. So yeah, let's move forward and understand Trivy vulnerability database. That is again an important component in Trivy architecture. Now, what is Trivy vulnerability database? So just imagine it as a police database where it logs all the details of all the criminals, where the criminal is coming from, what is the Aadhaar card ID. So just like the same way, it is a local optimized vulnerability database. It contains CVE, severity, fixed version, and it is located in cache Trivy. Okay. Now, if you want to visualize it, just take a reference of this folder. Now, when we are talking about Trivy vulnerability DB, so just imagine a folder where all the information regarding this regarding the security vulnerability has been logged here. Now, what sort of information is present? Basically, the CVE ID. Basically, it is the ID of the severity. Okay, and again, what version the issue was found and which version will fix the issue. That information is stored in Trivy vulnerability database, which is also used for knowing the threats. Okay, moving forward with the next thing. Now we talked about Trivy vulnerability database, and now we are going to talk about CVE data source. Where does Trivy get all the information from? Are they updating it manually or they are fetching it from multiple sources? So the answer is Trivy extracts the data from multiple sources. The first main important source is NVD, that is National Vulnerability Database, where all the bugs are being reported. Now, let's say you launch an application that is being used by every company. Okay, if there is an issue, so the patches actually raise an issue that this application contains an fix, and this can be mitigated with this code. Those things are logged in a national vulnerability database, and here basically they will get an ID, they will get an recognition, and everything is logged over here. What is the issue? How do we mitigate it? What would be the consequences if you deploy this? All the things are present over here. Second source of truth for vulnerability database is vendor advisories. Now it can be Ubuntu, it can be Red Hat, it can be Debian, it can be Alpine. Third would be GitHub security advisories. What is GitHub security advisories? Now, here GitHub is a community of all the developers. So all the issues raised by the development team, all the open source developer are being logged in these advisories. That is been taken again as a reference point in these data sources. So it becomes easier for Trivy to check what sort of issues can be arised apart from NVD and vendor advisories. So GitHub security advisories are also one of the important source of data source when it comes to Trivy data sources. And again, the last is package ecosystem, that is npm pip ruby second go. Okay. Now again, visualization. Now in the center you can see we have Trivy database, and here it is taking the sources from multiple sources. Now what sources it is taking from? Basically vendor advisories, GitHub security advisories, package manager, operating system, national vulnerability databases. So these are all the sources where Trivy database is taking the reference from, and it is storing in one single place. So whenever you are running your Trivy scan, this database is being taken as a reference where it is taking pull from all the related data sources. Now it took the data source, it analyzed the image. Now, on what basis it is doing the scoring? CVSS scoring. So, there are four level: low, medium, high, critical. Low stands between 0 to 3.9, medium start from 4 to 6.9, high stands from 7 to 8.9, and critical 9 to 10. Okay. Now, again, what factor it is considering the scoring pattern? First is a vector attack, second is attack complexity, third is privileges required, like what sort of privileges are required. Fourth is user interaction, whether be is it a behavioral change or when a user does a specific action, and based on that it is doing the scoring. Those are the factors. And the last is impact on CIA, that is confidentiality, integrity, and availability. If you want to understand the scoring pattern, again this visual will help you. Basically low 0.1 to 3.9, it is based on attack difficulty, user interaction, confidentiality impact, integrity impact, and availability impact. So basically based on these factor it is telling the CVSS score. Now what is CVSS score? CVSS stand for common vulnerability scoring system. Okay. Now in order to understand this scoring pattern, let us take one example that will give us an idea on what basis it is giving lower, high, medium, and critical severity. So let us take a real life example. Let's say a bug is requiring someone to click. So this will fall under lower severity. Second, a remote attack that needs no login. This becomes some higher severity. Third, a bug that leaks password. Again, we are exposing password, so this will fall under high severity. And the last one, the critical one, a bug that crashes the entire server. This will fall under critical. Now, based on these example, now you can understand on what basis these scoring are done, right? So what we did, we analyzed these data scan against Trivy vulnerability database. We understood how does the CVSS pattern works, on what basis it gives the numbering. Now let us go with the next component, the important component of Trivy architecture, that is matching engine. Now, what matching engine does? So basically what it does, whatever things we scan through Trivy vulnerability database, it will scan it through their own list. Okay, checking your item against the banned list. Now it compares the installed version versus the known vulnerability version. Let us take the very big example. You are using Python version 3.19 and the issue is found in version 3.20. So it will scan 19 and 20. So that is the actual job of matching engine. It will flag the matches if they find anything. It will assign the severity based on CVSS. Okay. Now we understand what actually CVSS is. It is a scoring pattern based on the severity, and based on the factors, it will give the severity number, and that is how it will generate an ID for us. Okay. Now matching engine, it will just match both the things and assign a CVSS score, and then it will pass it further to result formatter for us to see the output. Now, what sort of output we can expect? It can be a tabular format output, it can be a JSON output, it can be a serif output, it can be output in a template. We will be seeing the output in templates as well. I will show you how you can generate a beautiful PDF report or an HTML report when you want to run a scan against an image, right? So yeah, that was a report formatter. Now, we covered the main core concept of this video, that is the architecture of Trivy. Now, the question is where Trivy gets the data from. It is National Vulnerability Database. Second, vendor advisories, that is Ubuntu, Red Hat, Alpine. Third, GitHub advisories. And fourth is package ecosystem fits. NPM, PIP, Ruby, Go. All these provide the data. Now, let us understand the life cycle of Trivy database pipeline. So, behind the scene, Aqua Security maintains the backup pipeline. Uh, behind the scene, Aqua Security maintains the backend pipeline that builds the Trivy database. Now, how does it work? It collects the data from all these different sources. Now, when I tell all these different sources, we are talking about the different advisories it is taking reference from. NVD advisories, OS advisories, GitHub advisories, and package manager. So here, Aqua Security is the company who is taking care of maintaining this TV vulnerability database. Now, based on that, what is happening in the next level is it normalizes the data into single format. It removes the duplicated entries and conflicts. It compresses everything into a lightweight DB bundle. And this lightweight DB bundle is downloaded to your local client. So remember, whenever you are running Trivy image followed by Ubuntu latest, it actually updates the database. So that updated database is coming from this compressed place. And because the data is already compressed and the data is pre-processed, your scanning is even faster and you are able to generate the report in very no time. So in this video, we learned about the architecture of Trivy. We learned about artifact analyzer. We learned about Trivy vulnerability database. We understood what is the function of matching engine. We learned about how and what does a report formatter does. Okay, we understood where CVE gets the data from, where how does Trivy maintains the database. So there are multiple sources: package manager, operating system, GitHub security advisories. Okay, these are multiple data sources where the Trivy is maintaining its database. And let us understand how does this scan flow once again. So once you pull the Docker image, it actually the image is being analyzed using artifact analyzer. Then again, local query is run by Trivy vulnerability database. Now that database is again maintained by Aqua Security, which fetches the data from multiple sources: advisories, package manager, OS, and NVD. And then it is further passed to matching engine, where it matches the previous version and the current version. And based on those matching pattern, it gives the CVSS score. Now, on what basis CVSS score is been given? So basically, based on the criticality of the bug and the nature of the bug, it gives us the CVSS score. Now, once everything is done, it pass on everything to report formatter and it generates a beautiful report for us. So that is how Trivy is a simple, fast, reliable vulnerability scanning tool. I hope this gave you a very good idea about how does Trivy works behind the hood. What does the architecture of Trivy looks like? Next video is again a very important video. Why? Because I am going to tell you how to perform the scanning, but also how to fix it. We are going to fix the medium, low, and critical if possible. All the things we are going to cover in the next video. So stay tuned. It will be one of the best and important video that will help you in your learning journey. So yeah, that was all, and I will see you in the next one. All right, welcome back. So today is the video where we are going to actually test Trivy and we are going to see how does Trivy actually work. Till now, we covered the theory, how does Trivy works, where it is gathering the data from, and how it is formatting the result. So we learned how does thing works. Now in this video, we are going to do a practical demonstration and we are going to scan one of the known images from Docker Hub, that is Python 3.10. Why specifically this image? Because this image has few vulnerability and this will act as a perfect example for me to explain each and everything. I will literally tell you how do you read a Trivy report. So that is the main agenda of creating this video, right? Okay. Here you'll find Python 3.10 image. Okay, and I believe you are already done with your setup from AWS for the Trivy. If not, if you're doing it locally, that is also feasible. I am right now running these commands on my MacBook, and if you want to know how did it, so just go to Google and search for Trivy install on Mac. And will be two commands, but it would be through View Homebrew. So you just have to run through install Trivy and your work will be done. So I'll just show you the actual command that I use for installation. Just give me a moment and here I'll just find it in no time. Okay, so here is the Homebrew official macOS package provider. You just have to run brew install Trivy. It will take some time and then your Trivy will be installed. Now, let us start with the actual demonstration for Python 3.10. And here, let me just confirm the installation. So I'll just run Trivy -- version so that you can also verify which version of Trivy you are running in your system. Okay. Right now, I am on version 0.68.1. Vulnerability database is version 2. It was lastly updated on this date. Next update will be on 7th, and it was downloaded on 6th. Okay, so these are the basic details that we get when we run Trivy version. Now, let us actually start with the Trivy scan. So, how do we run a Trivy scan on an image? So just write Trivy image followed by the image name. Okay. Now, what is the image name here? So here the image name is Python 3.10. Let me just copy it and I'll paste it over here and the scanning will get started. Here, what it is saying, you need to update DB, downloading the vulnerability. DB meaning it is updating the database sources. Now, if you go back to architectural design, the four components we understood, here it is fetching the database information and Trivy already maintain it and that has been maintained by Aqua Security. Now it is fetching all the information from all the advisories and then it is compressing into a single one and it is downloading it locally. And then once everything is done, it is actually performing the scan. Now, here the match analyzer, report analyzer, all the things are working at the back end. It will take some time based on the size of image, based on the complexity, based on the libraries it is been taken care of, and then it will perform the report generation for us. Now, if you want to know how many components did we have, so if you go back to the previous stack, here the first thing that is working is the artifact analyzer that is actually analyzing the image. It is separating it into two sections: OS level vulnerabilities and application packages level vulnerability. Then it was updating the database. So if I go here and show you, here it is showing that need to update database. It is downloading the vulnerability database. So basically it is talking about Trivy vulnerability database. Now, what are the sources it is getting the data from? It is getting the data from GitHub advisories. It is getting the data from package manager. It is getting the database from the OS. All the things it is gathering the data and pulling it into one place. Okay, and also it is getting the data from NVD. Right now, based on the severity, now it will share the report to matching engine where it will match each and every report, and then the report formatter will generate a beautiful report in a tabular manner for us, and we will be able to see the report. Right now, you can see the report is generated. I'll just minimize it a little bit, and we'll go all the way to the bottom to understand what actually is happening over here. Okay. Now here, once everything is done, your main focus should be on the report summary, where it will give you the gist of all the things. Here it is saying in this image that is Python 3.10, it is using Debian version 13.2. The type is Debian, and here there are 1080 vulnerabilities. Okay. Now it is showing you the package level vulnerabilities which are present. So here a Python -pkg, there are two vulnerabilities. If you scroll all the way to the bottom, okay, here you'll find the minimized summary of each and everything that has been done. So the total vulnerabilities that has been scanned is 1080. There are 21 unknown vulnerability, out of which there are 721 low medium vulnerabilities and 231 medium level vulnerabilities, high are 107, and there is no critical vulnerability. Now, which one to give priority? So see, the first thing should be whenever we are talking about vulnerabilities, the critical one should be given the highest importance. Now, based on that, we will be fixing either the OS level image or the package level image. And then second level of priority should be given to high, then medium, and lastly low. Okay, so this is the sort of priority and severity that you can give while assigning it to the developer. Now, how do we read this report? See, here it has segregated into two level. One is OS level and second is package level. So right now the thing that we are seeing here is at OS level. Okay. Now how do we read it? So the library that is used here is APT. Okay. And then here the vulnerability that is been scanned is this. And here it is giving us a vulnerability ID. Now, on what basis it is giving the vulnerability? So see, here we have someone called a match analyzer vulnerability, which maintains the database of all the CVEs, and from there it is getting the vulnerability ID. So if I want to know more about it, I'll just copy the CVE ID and Google it. And second thing that I can do is I'll just click on this link which is given over here, and then I can actually read what is actually happening behind the scene. Now this has been maintained by Aqua Security. Okay. So here they'll give you the entire gist of what actually this issue is about. Okay. Here CV 2013774. It is for improper verification of cryptographic signature. Okay. It will tell you when it was published and when it was modified. What is the CVSS score? And here it is saying 3.7, which is low. And then it will tell what actually is the weakness. The product was does not verify or nor incorrectly it verifies the cryptographic signature of the data. Then it will tell affected software. Okay, now the affected vendor here is Debian, and the current image that we are using is using the vendor as Debian. So here we are also affected. And then if you want to know the references, it will give you all the references which are present, and that is how you read the reports. Okay. Now let us go with this table. Here it will give you library, vulnerability, severity, status, installed version, fixed version, and title. Now here we understood it is talking about library. Vulnerability, it is giving you the CVE ID. Okay. And then severity, basically it is low. It can be high, it can be medium, it can be critical. Now based on our application, we will resolve this severity. Now status, affected, clean or not. So basically it is affected. That's why it is saying that it is affected on version 303, but the fix is yet to come. If there is any fix, then it will be present over here. Okay. Now, if you want to know what is going over here, so it will give you the title, the gist of the issue that has been there. So it was found that the APT key in APT all version does not correctly. So if you want to know more, just click on the link. It will give you the entire document. Scroll all the way to the bottom, and here we'll find one reference where we are going to see where the fix for the package is also given. So let me just scroll down. I'll just search for a perfect example. Okay. So here you can see at a library level at Python package, you can see there are two medium vulnerability. And here you can see it is regarding the PIP, that is Python installation package manager. And then here you can see it has given a CVE ID, and then the severity is medium. The status is fixed. Earlier it was not fixed. And then the issue is with the version 2301. And if you upgrade it to 23.3, your issue will get resolved. And if you want to know more about this issue, just click on the link given over here, or you can directly go and search on Google the CVE ID which is given. It will directly take you to over here. Okay. Now here it will give you the actual just what actually is happening. It is telling when installing a package from Mercurial VCS URL or with pip to version 3.3, the specific Mercurial revision could be used to inject arbitrary configuration option to the HG clone. That is the config. Controlling the Mercurial configuration can modify how and which repository is installed. This vulnerability does not affect users who are installing from Mercurial. Okay, so it gave you the gist about what is actually happening over here. So just wanted to tell you, running a Trivy scan is literally very easy. It just seems very overwhelming when you are seeing the report, but if you have the clarity to read the report, it becomes very much easier. Okay, so here what is happening, we just ran one command, that is Trivy image followed by the image name, and then it updated the database, and then it downloaded the artifact, and then it actually ran the scan. Then once everything was done, it generated a report summary for us. And then with the help of artifact analyzer, it told us about OS level vulnerability, and it told us upon package level vulnerability. We saw what is the significance of CVE, what is the meaning of low severity, what is the meaning of status. So if it is affected, it will show you affected. If it is resolved, and it will tell you that the issue is resolved. All you need to worry is about the installed version and the fixed version. If there is an issue which is affected, then there will be a fix provided, and that fixed version will be present over here. Now it's upon you whether you you want to update the base image or the OS level image, that is upon you. Okay, you can update the application image or you can update the OS level image. Okay, these are the two things that you could do. But in the coming video, we are actually going to see how we can solve those level of criticality and vulnerabilities, right? In this video, we actually saw how do we run a Trivy scan on an image and how do we actually read a report. But if you want to run once again, so I'll just for a sort of revision, I'll just run one more command. Here I'll just search for one of the image from my own repo, which will give us the clarity how does Trivy scan work. So again, I'll use this profile summarizer image, and here I'll just write Trivy image followed by the image name, and here it is again updating the database, and it will run a scan throughout and it will give me the report. So that is how you run a scan on an image, and this is how the image has been generated. Now here you can see it gave us a summary. There are 11 vulnerabilities. The OS level that it is using is Alpine. Okay, here it is telling me the Alpine version is 322.2, and then it is telling, okay, the current installed version is 137R19, but the fix is given is 137.0-R20. Now, if you want to know more about it, either search the CVE ID or directly go through this URL. You will get each and every detail about this issue. Okay, so yeah, that was all. I hope you learned a lot in this video. We actually covered a lot, and we learned like how does Trivy scan work, how do we perform these operations, and what are the meaning of each and every field in a Trivy report. In the coming videos, we are actually going to see how do we resolve these issues with the severity critical, medium, and high. So yeah, that was all, and I will see you in the next one. All right, welcome back. In this video, we are going to further enhance our journey with Trivy. So in this video, we are going to learn about three main important flags that will make our life easier when we are dealing with Trivy. Okay, and entire thing, whatever we are going to do today is documented on the second repository, second subdirectory of Trivy tutorial. All you have to do is just go to the Trivy main flags, and here you will find the readme.md file where all the things has been documented. Okay, now here we know how do we use Trivy, how do we run basic scan, how do we see OS level issues and application level issues, right? Now in this video, we are going to see how we can differentiate it based on severity, now based on vulnerability type, and let's say if you are working with CI/CD, what is the exit code? These are all the things that we are going to cover today. So let us first see the theory, and then we are going to jump directly to the practical. So Trivy, using Trivy is easy, but controlling what Trivy shows, which vulnerability matters, and when it should fail your CI/CD pipeline, where the real skill begins. So this is where our new journey will get started. So in this guide, we are going to cover three most important flags that everyone should know. Okay, by default, Trivy shows all the vulnerabilities, that is low, medium, high, critical, and unknown. And if you care about only the important issues, that is critical and high, so this filter will come into your picture, that is -FN severity. So in order to find the severity which are of high and critical, you need to run Trivy image -FN severity high and critical followed by the image name. Okay, and then it will only show you the vulnerabilities that are of severity high and critical. Okay, so let us run this command and see how does it looks. So Trivy image -sev high and critical and Python 3.10. Now what it will do, it will update the database, and it will run the scan using application analyzer. It will break it down into two parts, that is OS level and package level management, and then it will show you the report that are of severity high and critical. Now once everything is done, it will show a report in a tabular manner, and that will take 10 to 20 seconds, and it will be displayed on your screen. So here you can see all the issues that are of type high and critical are displayed in the screen. Let me just go here, and here you can see the severity high. There are no critical, that's why it is showing 0 over here. But you got the gist how things work. But let's say if I only want to see the issues that are of type low, so instead of high and critical, I'll just run low over here, and you can see it will print the issues that are of low type. Make sure you're writing everything in uppercase so that it will render everything, and then it will print the issues on your screen. And here all the things that you see are of low category. So let me just scroll up, and here I can show you the severity type as low for all of these scan. And here you can see the severity is low for the scan that we ran just now. I hope you understand how does hyphen hyphen severity flag works. Okay, let us move forward, and here we are going to learn about vulner type, which stands for vulnerability type. So in Trivy, the vulnerabilities are categorized into two sections, that is OS level vulnerability and library level vulnerability. So let's say if you want to see the issues that are of OS level vulnerability, you just need to run command Trivy image hyphen hyphen vul type, and here you need to define the vulnerability type that you are looking for, that is OS. Now here if I go and I'll just clear the screen, I just increase the font, and here when I run Trivy image vulnerability type OS for the image Python 3.10. Here it actually showed the issue, okay, which are related to operating system. Okay, and here you can see it is using Debian 13.2. But if my requirement change somehow and I am just interested with the vulnerability that are with the libraries, okay, so I just run the command Trivy image vulnerability type library followed by the image name. Now, why it is useful? So, see, if you are someone who is dealing with infra and security, you will be just interested in OS level vulnerabilities. But if you are a developer who is fixing the issue, then you will be interested in package level management vulnerability or the issues that are coming through the libraries, so that you can directly fix in the requirement of TXT, patch it, update it, and the issue will get resolved. But if it is at infra level, then you have to run the command for OS. All right. I hope you understand one type flag. Here we covered OS level vulnerability and library level vulnerability. Okay. Now, coming up next, the third and the final flag, that is exit code. So it is used to fail the pipeline whenever we are using Trivy, because by default Trivy exits with code 0, which shows success even if it file vulnerabilities. But whenever we are dealing with CI/CD, let's say Jenkins, and we want to field a build which has serious issue, so CI/CD uses exit code 1 to block the deployment to post review for vulnerability. It actually helps you to strengthen the DevSecOps culture. Okay. Now, failure build of if higher critical issue is fine. So in your pipeline, you just have to add this SH in one of your step, and what it will do, it will just run a Trivy scan and it will find high and critical vulnerability in your Python 3.10 image, and if issues are found, then it will fail the pipeline, and this is the output that you will be getting. What will happen if you run this command directly? So what will happen if you run this command directly? Okay, so let us run this command and see what is the output that we will be getting after running this command. Okay, so again it will scan the DB, and this is the output that we are getting. But the same command, whenever it is executed in a pipeline, it will fail the pipeline and show you that due to these vulnerability the pipeline got failed, and your life will become easier to identify the high and critical vulnerability in a pipeline in a Docker image. And yeah, that is the basic use case of using exit code flag in Trivy. Okay, so let us revise whatever we did. Today we covered three flags, that is hyphen hyphen severity, that is used to filter important vulnerability. Second is hyphen hyphen vul type, which is used to filter OS level and library level vulnerabilities. Third is hyphen hyphen exit hyphen code, that is used to fail CI/CD pipeline on security issues. I hope these flags will definitely add value to your learning to filter out issues based on the Docker image. You can now try to implement this flag on multiple Docker images and try to explore how does the output differ. Even try it with, if you are working with severity, try it low, medium, high, critical, and unknown. Okay, just for the closure, just want to show you how you can run a report for low vulnerability. Let me clear the screen, and let's see if I want to find the severity that are of medium, because I didn't show you. It should be in capital letter, and followed by you have to provide the image name. So here the image is Python 3.10. It will scan the entire image and it will show you all the issues at OS level and at application level, that is library level, which are of severity medium. I hope this video did add value to your learning, and in the next video we are going to buckle up our learning with review. So yeah, that was all, and I will see you in the next one. In the next video, we are going to see how you can run the Trivy scan on a local image fix it, and then you push it to Docker Hub. Yeah, that was all, and I will see you in the next one. All right, welcome back. So in the previous video, we performed our first scan. We actually ran the Trivy command. We saw how does things look like and how do we explore it. This video in specific, we are going to learn how you can fix the local images at your system, right? Because if there is any way to fix it at local, this is the video that you are looking for. So let's say you have done a fresh new development and you want to see, is there any vulnerability present in my current code base? So you will just run the trivy command and you will find out what are the vulnerability present. So let's take a very vague example. Right now you are working on Python and there is a library that you're using. Let's say you're using pandas 3.5 and the issue is found. So if you're using at your level, you can just upgrade it to the version where the patch is present, right? So that is something that you can mitigate at the lower level itself, so that you can avoid pushing a vulnerability image into the production, right? So let us create a demo, and this is just specific for the demonstration. How does things will look like? So yeah, so initial thing is, let me just create a demo repository over here. So mkdir python demo, and I'll go to Python demo repository. I hope the font is visible to you. Now, let's say there is a Python file, and let me create a new file. So I'll create app.py, and here I'll write a print statement that would be hello there. So this is the Python file that we would be using, and I will be creating a Docker image out of it. Okay. Now the next thing would be I have to create a Docker file. So I'll just create a Docker file over here, Docker file, and here it would be from Python 3.10, and let's use a slime image. And then what I'm going to do, I'll run pip install flask, and then we are going to copy entirely the app.py file to the current root, and then we are going to run the file by using the command python followed by the file name app.py. Okay, and here we need one more space. Okay, and we should be good. Now let's say this is the file that I have created and I want to create a build out of it. So how do we create it? So docker build -t for tag, and I'll just create app with issue dot. Okay. Now here it will create an artifact based on the file which we created. And now what I'm going to do is I'm going to run a Trivy scan. But again, if I want to check how much time does it take, I'll just write time. Okay. Trivy image and followed by the image name. Now the image that we created here is app with issue, and it will be with the tag latest. Okay. Now why we are using time over here, basically we want to know how much time does it take to scan this image. Okay. So if you are aware of Trivy vulnerability database, so what it does, it take the multiple sources as a reference, club it together, and database has been maintained by aqua security. And that is the main reason we are using the time command to see how much time does it takes to scan this image. I'll press enter. So it will update the database and it will print the result on user screen. Okay. Now here you can see we have a vulnerability at a Python package, and here it's on PIP, that is the library, that is Python package manager. And here you can see the current install version is 23.0.1 and it is fixed in 23.3, which is latest. Okay. Now what we are going to do is we are going to fix this issue. Now fixing this issue is very much easier. We are going to just upgrade the Python installation packager, and then things will be good for us. So this entire severity issue will get mitigated and we should be good. Now let's see, if I want to understand more about this issue, I'll just click on this link and go through entire documentation which has been prepared by aqua security. There will be multiple references that would be supporting this result. Okay, so yeah, and also if you want to find out about this vulnerability, you just copy this entire CVE ID, paste it on Google, and you will get tons of detail about this vulnerability. Now let's say we figured out the issue, we have the installed version, we have the fix present. Now let us fix this issue. What I'm going to create is I'll just create a copy of the Docker file for our reference, and I'll just write and or cp docker file to docker file with the issue. Okay, it is done. Now what I'm going to do is I'm going to update the docker file with the patch. So when docker file, and here see the issue was with pip, that's python installation package. So I'll just write run pip install hyphen upgrade pip. Now what it will do, it will just upgrade python installation packager, and then the issue will get resolved. I will just save it as is. Okay, now I'll just rebuild the image. So app with issue, and I'll just write this one as 1 second. I'll just update it. 1 second. Okay, all right. I'll type it directly. So docker build hyphen t for tag, and I'll write app with fix dot. Here it will rebuild the file. Okay, and then once everything is done, we are going to run the Trivy scan again. So Trivy image app with fix, and here you can see that issue is resolved, and at local level only, before even pushing the artifact to docker hub, we mitigated the issue. And here whatever issues that you are looking is actually at os level. Okay, so that has been taken care by the infra team, but as a developer we fixed the issue that was creating the issue, right? In this video we learned how we can actually fix the Trivy issues when we are getting it over the console. We solved one medium level issue, and like if you can if you want to, you can just explore using multiple images in your own local projects. Okay, in the coming video I am going to actually tell you how you can fix the issue in the already pushed docker images and how do you patch it. So this thing will be something that we are going to learn in the next video. In this video we learn how do you find the issues that are present in your current local image, how do you fix it, and then once everything is done you can directly push it to docker hub. Right now, we also understand Trivy maintains a database, and that is the actual source of truth for it, where it is actually telling these are the data that is present. Right. So yeah, that was all in this video, and I will see you in the next one where we are going to actually fix a artifact which is already pushed to Docker Hub. So yeah, see you there. All right, welcome back. In the previous video, we learned how you can perform a local scan in your system when you are developing. Right. You can resolve all the dependencies issues before even pushing it to Docker Hub. Now here we are considering the case that you have pushed the image already to the artifact registry or into Docker Hub, and here you found one of the vulnerability that you need to get rid of. Right. This video specific covers that specific segment because here we are going to see how you can try to fix that issue, how you can patch it, and you can push the patched image back to the artifact, right? So yeah, let me go back to Docker Hub and I'll search one of the images that I have been using for the demonstration. I'll suggest everyone to use their own image which they have pushed. It can either be a hello world image, it can be a Java based image, doesn't matter. The steps remains the same. The things remains the same, and basically here we are trying to see how you can get rid of the issues. So the number of images you try to explore, you will get a clarity how things work over here. So the base thing that I'm going to do is I'll run Trivy image followed by the image name, and that will actually run a report for me, and it will give me the report in two level, that is at OS level and also at package level, package manager level, right? So that has been done by artifact analyzer. And let's say if I want to know how much time does it take to scan an image, I'll just have to write time Trivy image followed by the image name, and it will run the scan. Okay, and then it will tell how much time did it take. So here you can see the time has been printed. Okay, and these are the vulnerabilities that I can see as of now. Okay, so if I go to report summary, you can see the system type is Alpine and the vulnerabilities here are 12. Okay, and here you can see there are OS level vulnerabilities, and this is something that we are going to resolve today. Here we have vulnerability in busybox bin sh, c arcs, like PNG, SSL underscore client. And the best part is the fix for all of them is present. So let's say BusyBox, the issue was found in version 1.37.0-R19. The fix is given, the patch is given in 1.37.0-R20. And then we got a requirement from the team that we need to get rid of this issue. This is under high criticality. How do we resolve it? Okay. So let's take that scenario and let's update libpng. Okay. And the issue, the severity is high. Okay. That we need to get rid of. The version is 1.6.47-R0. The fix is been given the in 1.6.51-R0. And the latest patch you can see it's on 6.53. Okay. So basically, if we update this package, the issue will get resolved. How do we do it? So the first thing would be to go inside the documentation and get an understanding of the issue, what that actually issue is. Once you got the idea and you got the clarity what we are fixing, then things would make sense, right? So the next thing would be I will create one Docker file and I'll type the command bin Docker file. I'll just copy this package name. It would be easier for us. Okay. Now, what we are doing the fix for? So we are doing the fix for the base image that we just pulled. So the name of that image is, I'll copy it from here. Okay. And here you have to update this library. So before even that, you have to run the command apk update. It will update the package list and then apt upgrade hyphen no cache libkng. Now what it will do, here we have defined the base OS, okay, where the vulnerability are found. And then what we are going to do is we are going to update and refresh the artifactory. When I say artifactory, I am talking about the package manager. It will get a revised list of the fixed version. And then we are upgrading the package with the vulnerability with the latest version which is present. So I'll just save this file, escape pull and wq, and then I'll build one more image out of it. So docker build -t app web fix v1 dot. Make sure your Docker file is present in the same place where your image is present. Okay. So here we are getting an issue, and here it is saying invalid base image platform. Here it is saying the expected platform is Linux ARM64. So while we are building the image itself, at that time you have to provide the platform name. So hyphen platform, and the platform is Linux ARM64, and then try to build it again. One second. Okay. Now this time things should work, and here it is saying, okay, fail to resolve the process, that is bin sh-c apt update. Okay. And upgrade no cache did not complete it successfully. We have to get the details over here. All right, let us see what is the actual issue over here. So we made a very small mistake. Basically, we ran the command apk update over here, and basically we wrote apt upgrade over here. So basically, those are two different package managers. If I go to internet and search for Alpine package manager, okay, it will give me the name. Okay, so here Alpine make use of apk. So I'll just again edit the Docker file. And here I'll just edit this apt to apk, escape pull and wq again, and then we are going to rebuild this image once again since it was not completed. And now you can see the image is built. Now the thing is, I am going to run the scan again and see whether the issue for libpng is fixed or not. So I'll just write Trivy image apps with fix v1. Okay, it ran a scan, and here you can see that issue is gone. The issue with severity high is literally gone. Now, Shubham, you said this time we are going to fix all the vulnerabilities, and this image will be a security free issue. Like there won't be any issue in this image. How do we do that? So what I'm going to do is I'll open one more terminal for the reference. Let me just do a little bit of zoom so it would be easier for you. I'll go back to the directory where my Docker file is present. I'll just edit the Docker file and see, this is one of the very easiest work to do because we are just upgrading the packages. Okay. Now here, considering the fact that you have to get rid of all the vulnerabilities, we already fixed the image, but here just for learning purpose, we are resolving all the issues. So it is very much easy. See, since the fix for all the libraries are present, we are going to upgrade each and every one of them. So libpng is done. We are going to update busybox, then busybox shell, uh, and then the next would be that is the arcs. Okay, and lastly SSL client. See, the fix is already present, so it is easier for us to get rid of all the issues. And one more space, escape colon WQ. This time, let me build the image with the tag app with fix v2. Okay, I'm running the command once again. This time, it will perform one more round of updation. Here we got one error. Let us see what is the issue. Oh, the issue is we didn't build the image. So let us build the image first. So docker build hyphen -t dot and app quick fix v2. This will build the image again. This time when we run the Trivy scan, it would be very much easier. And we can see there are literally no issues in the image. So I'll run app with fix v2 command once again. Okay. And here, see, the report is generated and the vulnerabilities are zero and things are good for us. Now, what should be the next step once the image is done? Then again, tag the image and then push it to Docker Hub. Okay, so let us tag the image. So Docker tag app with issue v2 with. I'll just keep the name safe. Colony v2. What was the name of the image? Check. App with fix. Okay, so this is app with fix. Okay, and what I'm going to do is docker push. Okay, now what it will do, the new tagged image will get pushed to Artifactory and the image with issue is been fixed and we are directly pushing into the Docker Hub. Now, once again, as a check from our side, we are going to run one more round of scan in this new image. So once the image is pushed, I'll just recheck whether it is present into the Docker Hub account. I'll go back to Profile Summarizer. If I go to tags, there should be v2 tag, which is just posted a minute ago, which is this one, and things are here, right? Now the next thing is I'll run one more round of scan in this image, the new image which we created. So Trivy image followed by profile summarizer, and yes, our work is done. You can see the issue is resolved and things are good for us. So yeah, in this video we learned how you can get rid of the issues for the images which are already pushed into Docker Hub. And if you want to know a deep understanding of whatever we did, so basically here I have already documented it into the repository. So here like what we did as a summary, we can just go through it. So here we did a scan on GitHub Profile Summarizer, which was a Docker image which is pushed into Docker Hub. Okay, here we performed an initial scan. We found there are 10 vulnerabilities, and then there were two high critical, low and medium vulnerabilities. After running the Trivy image command, we got this sort of output. And we also learned that there was a vulnerability which was present on version R90, but it was fixed on version R20. So we get rid of that issue first. And then once everything was done, we get rid of it and we pushed it into the Docker Hub. So our flow was like we wrote the code, we pushed the Docker image, ran a scan, and then we fixed the issue. So that is something that we did today. And initially we updated the package libpng, and that command is written over here, documented over here. So you can just take reference from here. And then if you want to get the final result, so the final result was like we literally get rid of all the issues that were present and things were good for us. Now, if you want the final Docker file that we used, it is also present over here. You can just use it for reference, but I would recommend to you to try it on your images, so it would be easier for you to understand and get rid of all the vulnerabilities which are present. Now, is this the only way that you can use for getting rid of the issues? So no, there are. So is this the only way to get rid of the issues? So definitely no, there are multiple ways also, but this is one of the scenario that we consider to get rid of the issues, right? So yeah, I hope you learned a lot in this video, and yeah, I will see you in the next one. Thank you very much and keep learning. Trivy, Gripe, Docker Scout. Now, which one to choose? Because all of them promise that they are doing the container security. As a beginner, this might be a point of question for you to understand which one should I proceed with. And in this video, I'm going to tell you why you should consider Trivy in the very first place. So yeah, let's get started. All right, so today we are going to compare Trivy, Docker Scout, and Gripe. So that would be at a very high level. We are not going to do a deep dive. We are going to see everything at surface level, and I will give you a reason why we should consider Trivy in the very first place when it comes to container security and DevSecOps practices. Right? We are not going to do any enterprise sales talk here. Just raw everything as is. Right? So what are these tools? Okay. So let us first understand what each tool is meant for. So Trivy is all-in-one security tool, security scanner tool. Till now, we have seen what are the multiple use cases that Trivy has done and how does it help us to mitigate the vulnerabilities and how beautifully things are being generated, right? Gripe is again a vulnerability scanner focused on SBOM, software bill of materials. That is Docker Scout, okay? That is Docker's native image analysis and recommendation tool, okay? You don't even have to install anything when it comes to Docker Scout. All you have to do is just Docker login and you will be able to run the analysis in Docker Scout. Okay. All three scan the Docker images, but they are designed for different purposes. Okay. So we already saw how does Trivy work. So basically you just have to run the Trivy command, that is Trivy image followed by the image name, and the things are done. Now, if you want to see the severity, we have multiple flags, which we have shown in the previous video. Okay. Now, there are multiple options for the installation. If you are a Mac user, you make use of Brew. If you are a Linux user, there are multiple application packages that are available for us to install Trivy. In short, Trivy gave us a very free hand when it comes to image security scanning. Right now, second thing is why it is beneficial for us, because there is no need to log in. When it comes to Docker Scout, you have to explicitly log into your Docker Hub account, but here you don't have to log into your any account. Second is it is a single binary and it works immediately. It will update the database and it will show the result on your screen. So that's the reason we are considering Trivy in the very first place. Second, it is very easy to install, and third is it is often used together with SIP. Okay. Now, let's come to Docker Scout. So, Docker Scout requires Docker CLI, Docker login, and Docker desktop if you are using it on Mac or any other system. Okay. But here, the best part is Trivy has less setup friction. The thing is, you don't have to log in, you don't have to set up anything. All you have to do is run the binary, and then you're good to go with the setup. So here we have Docker Scout, and second is scan speed and simplicity. Trivy, on contrary, when it comes to Docker Scout and Gripe, it is very much fast. It updates the vulnerability database automatically. It has multiple sources of database where which is maintained by Aqua Security. Third, there is a very simple output that the CLI returns when we run the command Trivy image followed by the image name. In short, Trivy is very good tool. Now, when it comes to Gripe is also fast. The output is more security oriented, but it becomes very difficult for someone as a beginner to understand what Gripe is doing. And second is Gripe is completely centric to SBOM, that is software bill of material. Now, when it comes to Docker Scout, it has a clean UI and inside. It is slower for repetitive CLI scan, and there are more opinion and guidance that is required when it comes to Docker Scout CLI. But the thing is, when I personally used Docker Scout, I found that the UI can be much better when it comes to CLI. But when it comes to Trivy, you have everything in a tabular manner. You know what is the current installed version, what is the severity, against which version the fix has been provided. That thing is something that you can find in Trivy, but not in Docker Scout. So that's the reason I will share you one picture where it will show you the comparison. Where does Trivy wins against Docker Scout and Gripe? Okay, so in short, Trivy is one tool for many scan. Gripe is excellent for vulnerability scanning and accuracy, but it is SBOM driven. Third is Docker Scout. So it provides great insight, but it is tightly coupled to Docker. You have to set up your Docker account. But when it comes to Trivy, no need to do external setup. All you have to do is install the package, run it, and things will be done for you. Okay. Now moving forward, so now let us discuss where does Trivy actually wins. Okay, so Trivy is the best choice when you are new to DevSecOps. Second, you want fast result with minimal output. Third, you want one tool for images, configs, infrastructure as a code. You are building tutorial demos or lab. You want the tools grow with you. So that's why Trivy is often the first security tool that every DevSecOps engineer learns. Now comes to when Docker Gripe or Docker Scout makes sense. To be fair, Trivy isn't the only option. You have to choose Gripe when you are dealing with SBOM, where SBOM first security tool is your main goal. Okay, and when you should consider Docker Scout basically when you lively interact with Docker desktop and you want a visual recommendation for upgrading hints. But for learning and automation and flexibility, Trivy usually comes the first. Okay. So in this video, we compared Trivy, Gripe, and Docker Scout. Trivy is simple, fast, and all-in-one tool. Gripe is strong for software bill of material. It is focused to that specific area. Docker Scout is Docker native insights. It provides Docker native insights for us. So for beginners and for daily DevOps work, Trivy is often the most practical choice. So yeah, that was all. In this video, we saw a comparison between Trivy, Docker Scout, and Gripe. I hope you got to know a fundamental idea what is the difference between Gripe, Docker Scout, and Trivy, and why we are considering Trivy in the very much place. Okay. So yeah, that was all, and I will see you in the next one. All right, welcome back. Till now, we have been running the Trivy commands to find out the vulnerabilities that are present in an image. Okay, we were getting to know the fine-tuned details of an image. We were getting what are the OS level vulnerability, what are the package level vulnerability that were present on image. But in reality, when you are sharing this report with the security team, you are not copying the console output and sharing with the team. They need something shareable, something readable. Okay, and that cannot be a console output, right? We need to share an artifact to the team. And in this video, we are going to generate an artifact of the Trivy report. And yeah, that's the main agenda of this video. So basically, we are going to refer the Aqua Security main report that they have generated. So we are going to perform the same. Here we will be sharing one artifact. It would be a wonderful report that we would be generating, not the console output, but an actual HTML report that you would be generating for the security team. All right, so let's get started. So right now you can see I am on the Aqua Security official GitHub account. Here you have to go to the Trivy. Okay, in the Trivy repository, you have to navigate to contrib section, and this is the exact section where you will find the html.tpl. Now this is the template that we are looking for. Okay, now the thing is we have to download this template. So before you download, just click on raw so that you get the raw content over here. Copy the URL and go to the terminal. Now let me just run the command curl-o, and this will be html.tpl and followed by the link that we just copied. Click on enter. Now it downloaded that HTML template. Now if I want to read that HTML template, I'll just run cat, and you can see it is just in skeleton that is currently present. But it requires a data that needs to be input over here, right? So just imagine it as just like a variable. We just have a key. Now it's just waiting for a value. Okay, now where do we generate the value from? Okay, so we are just going to run the same command, that is, let me clear the screen, and here I'll try Trivy image, and let's take Python 3.10 again, 3.10 hyphens line, and it will run the scan and will generate the report over the console. But this is not the agenda that we are looking for, right? This we have been looking from the starting itself. We want a representable output, okay, an HTML for a template that we downloaded. Okay, so let us rerun the same command, but here we are going to add few more options. Okay, let me clear the screen first so it would be visible for you. So clear, and let me just increase the font. Okay, hope now it is visible to you. And here we are going to make use of the same command, but we are going to add few more flags. Okay, now here we want to put this output to that template. So for that, I'll just write hyphen format, and the format will be based on the template that we are going to pass. So template. Now, how would Trivy know where the template is present? Right now, we downloaded it in the current source, right? So let me just write the template source. So template path is template here, and since it is present in the current root location, I'll just write the name of the template, that is html.tpl. Make sure you're writing the spelling correct. If you are missing any of the spellings, it will create an issue. Okay, and then what would be the name of the report that you would like to tell? Okay, so here it would be trivy.html. You can just rename it as per your use. Let me break down the command that we used. See, trivy image followed by the image remains constant. There are three flags that we are using right now. First is hyphen format. Now here we are specifying trivy that we are going to make use of a template, and where that template is stored. So basically here we are passing the path of the template. Now since it is stored in the current location, we don't have to worry about it. So we just pass the name of the template that we want to use, and what should be the name of the file. So that would be a trivy.html. Now once everything is done, just click on enter. It will run the scan, it will store the output into the Trivy file, and then we are good. See, the Trivy scan is completed. Now if I do long list, you can see trivy.html file is present over here. And now let me show you the wonderful report that we have generated in Trivy. So let me open the trivy.html file, open trivy.html, and here you can see the wonderful report that I was talking about is present over here. So whatever we were generating over the console is now live in front of us. You can see it has multiple colors, like low is indicated in green, meaning you don't have to worry about it, right? Medium is again given a color. There must be a color for critical also. It is usually red in color. You can see links are also present. It is pretty much readable, and we can literally share it with the team. Also, one more thing that it's generating is, like, when this Trivy report was generated, all the timestamp is generated over here. I hope you learned a lot in this video, where we can share this artifact with the security team, right? In this video, we learned how you can generate a Trivy report and share it with the world. But is this the stop of this series? No. Next video is definitely going to be very much special, because we are not going to do the manual stuff again and again. So yeah, that was all for this video, and keep learning. Thank you very much, and I will see you in the next one. All right, welcome back. Till now, we have been working with Docker images. We were scanning the image, we were getting a report. We even saw how we can format a report. We saw how you can extract the report in HTML. But this was after the artifact is created. But is there any way that we can scan those things or entire code at local itself? Yes, there is a way. With the help of Trivy file system, we can do it, right? If you remember, in one of the videos, we actually did a comparison for Trivy, Gripe, and Docker Scout, and Trivy won. Okay, so basically this is something that we are going to make use of. In this video, we are going to see how does file system work, what is secret, and how does Trivy helps us in scanning the secrets, right? So yeah, in this video, let us see the theory behind how does secret detection is been done with the help of Trivy. Next video will be a demonstration for the same, where we are going to see the practical implementation of Trivy file system. But before even we proceed forward, what actually is a secret? Okay, let's take a very big example. There is Ram and Sham. Ram says that I have a secret to share, that I ate two mangoes, then don't share it to anyone else. Now, Sham, being a very best friend, he doesn't share it with anyone. So just like that, secret is something that you keep with yourself, right? It's not something that you expose it to the world. It comes to secret in cloud and in IT, a secret is a sensitive data that should never be shared in public. Now, what sort of things can be considered as a secret? It can be your API key, it can be your access token, it can be your password, it can be your private key, or it can be your JSON web token. Okay, it can be anything that requires an authentication where we are writing something as a password will be considered as secret. Now, what will happen if these secrets are leaked? Okay. If these secrets are leaked, there can be multiple outcomes, but out of those things, these are the top three outcomes that can happen. You are exposing your cloud resources, your data can be theft, and third is it can lead to your account compromise. Now let's just take a very vague example. 10 to 12 years ago from now, let's say on 2010, we were able to log into Facebook by using username and password, right? But if you share that username, your email ID and password is someone else, he or she will be able to log in with that ID, right? Your account will get compromised because back that time MFA was there, but we were not aware of it, right? Now, since MFA is there, it added one more layer of security so that we are making sure that our account is not compromised. But in that same sense, if your secret is leaked, your GitHub GPG key is leaked, your AWS token is leaked, your account can get compromised. You can even expose your cloud resources. So that can happen, right? So that is the reason we should understand why secret scanning matters. Okay, because why it happens, because most of the secrets are hard coded in the code. Now let us understand why things are been hard coded into the code. Now when it comes to development, the developers, in order to save their time, okay, in order to get rid of the dependency, he hard code the tokens into the code, and then he works. Now everything works fine, then he pushes the code into GitHub. Now there is some sort of security, like when you push the changes to GitHub, and if it detects any sort of secrets, it at the merge level only tells that there are secret present, kindly remove it. But if you even do a force push, it will merge the code and your secrets are been exported into the application, right? So that can be one of the reason why secrets are been hard coded, and due to that reason it leads to secret leak. Okay. Now second is .env files are been committed. Now these are the .env file where all the secrets are been handled, right? And third is why these leaks happen, because the configuration files are copied blindly. We don't even check it. So these are the top three reasons why secret leak happens. Okay. Now, how does Trivy helps us when it comes to Trivy scanning, secret scanning? So the secret scanning catches the problem before we create the Docker file, before it goes to CI/CD or production. And how it can be done? It can be done with the help of Trivy. Now, before even we see how does it works, we first need to learn how does Trivy detects its secrets. So basically, there is no AI evolved in this. Okay, basically Trivy uses pattern-based detection, and it is not just a guesswork. It scans for the file which are known for, basically it scans for the known formats, known for secret format. It can be a common identical credential structure, and there can be some high entropy strings, and there can be a provider for specific patterns. Now let us take a very big example. When it comes to GPG keys, we are talking about, it can be GitHub token, it can be AWS token, it can be Google Cloud tokens. Those tokens basically they have a specific pattern. Those pattern is been noted down in one of the form, and that is been present in a vulnerability database. So when we run Trivy file scan, at that time it run the scan and it will show that these are the secrets that are been exposed. So think of it as a security awareness. It scans a regex. Okay, a regex is a pattern that is run throughout your code and will tell you these are the things that are been exposed. Okay, and that is how it is helping us to identify what sort of secret has been passed down. Now, what are the pattern types that it scans? It can be AWS access key, it can be GitHub token, it can be generic password, it can be private keys, and it can be high entropy string, that is JWT secrets. I will attach one screenshot which will help you to visualize like how does each of these keys and tokens look like. Okay. Now, we understood how does it perform the scan. Basically it performs a regex scan and what sort of things that it is looking for. But where it is looking for, it is finding the scan, it is running the scans on few of the files, that is .env file, it can be YAML file, JSON file, Python file, Docker file, and shell script. So the secret scan be present at anywhere, not just in .env. It can be hard coded into the file also. So that's the reason it scans everything. Now, what is false positive? Now, see, not every detected secret is real. False positive can happen. But what is false positive? Basically, since it is scanning a pattern, okay, it will scan your examples too. And at that time, it will flag that, hey, I found a secret and can you please check it? Basically, when it comes to .env, you will write some example pattern, right? In .env, you just add you have to add AWS token over here, or you can give an example that the GPG XXX. So it will just scan that pattern and will tell you, I found that in .env there is a secret that has been exported, but can you please re-verify whether it is the actual secret that you are passing, or it is just an example that you want the further developer to take a reference for, right? So positive can happen when the document can contain example, the test data looks like a real one, the placeholder string matches the pattern. So Trivy is considerative by design. So basically, just like a scanner that will help you to mitigate the issue before even you push it to the GitHub. So better safe than sorry. Now, what does Trivy doesn't do? Trivy does not validate secret. It does not check if the keys are active. It does not contact the cloud provider. Okay, it only answers, does it look like a secret pattern? And that's all Trivy file system does. So key takeaways from this video: Trivy detects the secret using the patterns. Cloud keys and tokens are easier to detect. Third, generic password may cause noise. That's why it will scan everything. False positive may be expected. And fifth, it will catch the secrets before even the incident happened. So these are the key takeaways from this video. Okay. In the next video, we are going to see how does Trivy file system works, a hands-on demonstration. Here we covered the theory and how and what the things are working. Okay, so yeah, that was all, and I will see you in the next one. Thank you very much. Most of the security breaches doesn't happen by the hacker. It happens by someone who accidentally commit a secret into the repository. In this video, we are going to see how you can detect it in the earliest stage itself. In the previous video, we saw the theory behind it, what is Trivy file system, and here we are going to do a practical demonstration for the same. But before even we move forward, I just wanted to give you an heads up. Whatever we have been doing so far, like generation of Trivy report, each and everything is been documented in this repository. All you have to do is you have to go to the subdirectory and you'll find entire documentation present over here. Okay. All you have to do is just go to the repository, read the readme MD file, and you will be good to go. Okay. So also, whatever we are going to do today, that would be falling under sub repository number 7, and each demo file and everything is documented over here. Here you can see previous secret scanning sample secret demo is here. Okay, and all the disclaimer is present that this project is specifically created for dummy purpose, just for our own experience. How does secrets look like, how does TV works internally, and how we can mitigate these issues. Okay, so let me help you to go through each and every file that we are going to use today. So usually it has been observed that maximum the secret file are been exported in .env file. So we have created a dummy env file where entire secret file has been exposed. These files are fake. We are just using it for demonstration purpose. Okay, there is nothing that you can see is real. In the app.py file, we have added the AWS key and the secret key along with the database URL just to know what sort of details Trivy catches. Next is in the config YAML, we have passed the database username password along with host and port number. In the AWS param, you see we have passed AWS access key and secret key. Next, in the Docker file, sometimes what happens, we hard code the username and password. So here we have hard coded the database password and the API token. When it comes to documentation, yes, sometimes we do expose some secrets in documentation, but those are usually for reference purpose. For example, it would be for example value. Now, readme MD. So here basically entire documentation for the project has been written. And in this settings JSON, usually you can see here we have passed the API key, JWT secret, and SMTP password. Okay. So that was the basic structure which will help us to understand Trivy file system. Let me go to the terminal and let me try to do the actual scanning there. We are going to see how does Trivy file system work. Okay, so right now I am in my terminal and let me run the command and show you how does Trivy file system work. So you just have to write the command Trivy fs for file system. Okay, and here we want to do the scanning. So scanners, and here we are scanning the secret. So secret. Okay, and let's say we want to skip the files. Let's say mostly the MD files are of no use because here we are writing the values just for reference purpose. Those are the dummy values. So we are interested in only the files which are related to the code. So I'll just write skip files, and everything that starts with that ends with .md should be ignored, and all the coding files are present here. Okay, let me just correct the spelling. It's Trivy. Here you can see it's scanned immediately and entire thing is present into our screen. Okay, let us see the summary report. You can see in the .env there are two secret exposed. Okay, in the app.py you can see there is one secret that has been found. In the setting JSON you can see one secret has been found. Okay, if you scroll down here it will show you on which file what sort of secrets are present. Okay, so in .env on line number 7 it found GitHub token. Okay, now again if you go to .env on line number 7 you can see GitHub GPG token is present. That is something has been identified by Trivy. Second, if you scroll down into the Stripe section, it found the Stripe API key again on the same env file in line number 9. You can see Stripe API key is also been detected over here. And again, if you scroll down in the app.py, it found the secrets. Okay. Now on which line? You can see on line number 3, it found AWS secret key. So if you go to the file name app.py, you will find the secret key is present in line number 3. That is again a fake one, but yeah, since we are doing a demonstration, we are actually seeing how does it works. It is actually showing us the result. These are the secret that we found in the settings.json. Okay, it found API key that is currently present over here. That is on line number 3. I'll go to settings.json. On line number 3, API key is present. Okay. Now, Shubham, you might be getting one question. Let's say if these are just for dummy purpose, how do we get rid of it? So the answer is simple. In the skip file section only, when you are writing the command, just add those files and those files will get excluded, right? In this video, we saw how does things work, how does Trivy file system work, okay? In this video, we saw how the Trivy file system works. We saw how you can run a Trivy file system command to extract the secrets from your code base. And let's say by accidentally also, you just push this code to GitHub. There is one more guardian that is helping you out to find the secrets. Let's say if there is a GPG key, right? There is a RAC key. GitHub will give you a mail that an RSA key has been found. In order to fix it, just click on the button. I'll show you a screenshot which I just got when I pushed this code into the repository. So there are multiple Guardian who are waiting for supporting us, right? So yeah, that was all, and I will see you in the next one. Till now, we have been securing Docker images. We have been scanning the Docker images. We have been scanning the Trivy file system. We were checking whether there is any issue present in a local system or not before even we push the changes to GitHub. Now, considering a scenario that the thing is already pushed to GitHub, is there any way that we can scan all the files, all the config file, all the env file, all the secret file, all the infrastructure file? So yes, Trivy has the answer for that as well. In this video, we are going to learn how you can scan the entire GitHub repository without even cloning it. Okay, I'm going to tell you both the methods. If the repo is present in your local, then how would you scan it? And if the repo is already present in the GitHub repo, how you can scan a remote repo. Okay, so this video will be one of the important video because here we are going to scan the entire GitHub repository, right? So without further ado, let us first discuss about what actually is Trivy repo. Okay, so Trivy repo is a command which is used to scan the entire GitHub directory. Okay, it is used for scanning multiple things, which includes security vulnerability. Now that security vulnerability can be at library or can be at package level.
It is used for scanning the infrastructure as code. It is used for scanning the secret, such as password, API keys, tokens, and it is also used to scan the library dependencies such as Java, Python, Go, Node, and many more. So it can also be integrated with CI/CD so that if the things are already been pushed to GitHub, you can just run a monthly scan and check how many secret is been exposed by the developer to your repository, right? So yeah, enough of discussion. Let us do the practical hands-on. So let us cover the first scenario where we are considering that things are already loaded into your local system. So without even using Trivy file system, we are going to make use of Trivy repo. So right now, if you are aware, I am using the same repository which we are using for our documentation. And here I am going to run the Trivy repo command. So it is very much easier. So Trivy repo followed by the repo name. So see, since it is already cloned and I am inside that repo, I'll just add a dot and it will scan the entire repository and will print the results on my user screen. Pretty simple as it used to be. Okay, so this is the power of Trivy. It literally give us that freedom to scan the repository based on need. Okay, now let's say if I only want to see the issues that are of severity critical. So hyphen severity. It should be critical. Okay, so only the critical issues will be listed over here. So right now we saw a very vague example. We considered that, okay, the repository is already cloned into your system, but what if the repository is present at GitHub and you want to scan it? How do you do it? So it is very much easy again. So in order to demonstrate the remote repository scanning, we are going to make use of WebGoat. So what WebGoat is? So WebGoat is a deliberately insecure application that is used for testing purpose. So that's the main reason why I am choosing this application. So if you go through the introduction, it will give you what actually it is used for. WebGoat, a deliberately insecure web application. The title itself suggests WebGoat is a deliberately insecure web app maintained by OAuth designed to teach web application security lessons. This program is a demonstration of common server-side application flaws. If you want to know more about it, just go through the README. Entire detail is written over here, and you can go through this application. So that's the basic reason why I choose this repository for scanning. Okay, so let's say this is the application, this is the repository that we have to scan. So what I'll do, I'll just copy the URL. Okay, that is the GitHub repo link, and I'll go back to the terminal, and again we are going to fire the same command. So Trivy repo, and here I only want to see the issues that are of severity high. So hyphen severity, and it should be of severity high and followed by the repo. Okay, now what it will do, it will scan entire thing. It will update the database. It will go to each and every file. It will scan for tokens, password, API key, API tokens, everything. Okay, it will even go to the .env if it is present. Okay, so all the things that it will be going through, all the things it will go through in an iterative manner and will print the report on the user screen. So if you can see, entire report is now generated, and this is the power of Trivy repo. And literally it is very wonderful report where you can actually see the vulnerabilities. Here you can see there are 23 vulnerabilities that are of severity high. And again, by looking at this report itself, you can tell that, okay, the current installed version is version 145 and it can be fixed by upgrading it to version, let's say 149, or you can directly upgrade it to the latest version, that is 1.4.18. So that is the power of Trivy repository. In this video, we learn how you can secure a repository, how you can run a scan over a GitHub repository. Also, we saw a second method, that is how you can run a scan on a local repo which you have cloned from GitHub itself, right? So yeah, that was all, and I will see you in the next one. Keep learning.
All right, welcome back. In this video, we are going to discuss about SBOM. Now, what actually SBOM is? Software Bill of Material. So that is something that we are going to cover today. Along with it, we are going to cover two more components, that is Cyclone DX and SPDX. Now, what actually SPDX is and what actually Cyclone DX is,
this is something that is the agenda of this video. That is something that we are going to discuss today. Okay. Now, what is SBOM? Okay. Now, before even we move further and discuss about SBOM, let us first understand in a very vague analogy so that we have a clear understanding what actually SBOM is. Okay. Now, imagine you have a chips packet and just behind it, you will find the list of ingredients that has been used. You will find what all composition is been used for oats, honey, almonds, and based on that, okay, you will get an idea that these are the things that are used. Basically, we are talking about the composition of the ingredient. Likewise, the same way, a software bill of materials come into picture that will help us to identify the inventory of the components. It will give you multiple details. For example, what versions has been used, what is the UI framework that has been used, what is the database that is being utilized, what are the core libraries that are being utilized. These are all the informations that software bill of material SBOM gives us. Okay. Now, what actually SBOM is? So SBOM stands for software bill of materials. It is a detailed inventory of everything inside a software artifact. It is just like a list of ingredients for your application. Now, what answer does SBOM provides us? So SBOM gives us the answer like what components are used, which versions are being utilized, where did they came from. So these are the three things that SBOM gives us the answer for. Okay. Now, why SBOM is important? Because in modern software, it uses open source library. It has deep dependency chain. It pulls code from many sources. That is the power of Trivy, and that's the reason we are learning SBOM with Trivy. Okay. Now, what SBOM gives us? So basically, SBOM gives us the visibility, stability, and faster security response. Now, what will happen if there is no SBOM? So you don't know what is there inside your application. Vulnerability response will be slow and compliance becomes difficult. So that is the difficulty you will be facing when you don't have SBOM. Okay. Now, what are the common SBOM formats? So there are two industry standard formats. First is Cyclone DX and secondly SPDX. So both are machine readable, industry accepted, and tool agnostic. Now let us understand each one of them one by one. First, let us understand what actually is Cyclone DX. So Cyclone DX is created by OAuth. It is designed for application security. It is lightweight and modern, and it is widely used in DevSecOps. It is best suited for vulnerability management and cloud native application. Now, let us understand SPDX, that is Software Package Data Exchange. Okay, it is maintained by Linux Foundation, whereas Cyclone DX is maintained by OAuth. Okay, it is older and more formal. It strongly focuses on license and compliance, whereas it is Cyclone DX usually focuses on vulnerability management. Okay, so third is it is used heavily in enterprise and in legal audits. So what it is best suited for? It is best suited for legal compliance, legal review, and regulatory environments. Here you can find a comparison between Cyclone DX and SPDX. So Cyclone DX focuses on security, whereas SPDX focuses on compliance and licensing. Cyclone DX is created by OWASP, SPDX created by Linux Foundation. So CI/CD in terms of CI/CD, Cyclone DX is user friendly. SPDX might not be. And in terms of vulnerability use, so Cyclone DX has a good use case. Why? Because it pulls data from multiple sources, whereas SPDX is only maintained by the Linux Foundation. So in terms of license, then SPDX is good, whereas Cyclone DX has basic information that it will do. But each tool is used for its own purpose. That's the reason we saw the difference between Cyclone DX and SPDX. Okay, when it comes to DevSecOps usage, we'll use Cyclone DX, but when it comes to license and compliance, we'll use SPDX. Okay. Now, SBOM is not a one-time activity because it is related to security. So it is important to know that SBOM must be regenerated. Every build and version needs its own SBOM, and old SBOM become outdated. So it needs to be updated every time. So SBOM is a living artifact. So key takeaways from this video: SBOM is equals to inventory of the system component. It is essential for supply chain security. We learned about Cyclone DX and SPDX. Cyclone DX is security focused, whereas SPDX is compliance focused. Trivy can generate both, and SBOM complements vulnerability scanning. So yeah, that was all in this video. In the next video, we are going to see how we can do the practical demonstration for SPDX and Cyclones with the help of Trivy. So yeah, that was all, and I will see you in the next one. All right, welcome back. In this video, we are going to do a practical demonstration of Cyclone DX and SBOM scans with the help of Trivy. Okay. So all you have to do is just go on Google and search for SBOM Trivy, and this will be the first link that you will be redirected to, and this will be the documentation that you would be referring to. Okay. Now again, we have already gone through the theory, so we won't be jumping on the theory. Okay. But once again, as a revision, Cyclone DX depends like mostly focuses on scanning on vulnerability. However, SPDX is mostly focused on licensing, right? Okay. So these are the two commands that TB would be utilizing, okay, as a reference. Okay. Now what it does, it will again, so treat the image followed by the image name. That structure remains the constant. The only thing that we are adding over here is we're storing the output in result.json, and then the format that we want to do is it would be an XPDX format. Okay. So per package dependencies. So what I'll do, I'll just copy this entirely, and this is an XPDX SBOM scan. Okay. I'll go to the terminal. Okay. And I'll just put this fire this command and just press on enter. Okay. Now what it will do, it will just scan and store the result on result.json. When I do a cat on result.json, this is the output that we are getting. Okay. Now here you can see we are getting the report such as it depends on, that is the relation type over here. There is an SPDX element ID and there is an a related XPDX element. Okay. And right now it is difficult for us to understand what actually the thing is trying to say. So we need a visualizer which will help us to visualize what the report is trying to say. Go to Google and search for SPDX viewer. Okay. And here you have something called Rancher. Okay. This is a very good tool that I am using for visualization. All you have to do is whatever output that we had stored in result.json, you just have to import it. So I'll just click on import, and here you can see we are getting the visualization. How do we read it? Okay. Now here it is telling us the SPDX version, that is 2.3. This is the license version, the unique license number CC0-1.2. Reference ID, that is SPDX reference document, and it is created by which organization? So again, maintained by Aqua Security, and the tool used is Trivy, and the documentation namespace. Now here you can see there are multiple packages that are currently present. Now here we are getting the information what packages are used by Alpine. Okay, and it is showing Alpine 3.15 base layout, keys, APK tools, busybox. These are all the packages that are inside that Alpine image. Okay, and again here you can see the version, the license, and the XPDX reference ID. Now let's say if I copy this reference ID and I go to the relationship. Now, if you remember here, we were getting the depends on section, and this is the area that defines, that is giving us the clarity that what sort of image is dependent on what sort of services. So if I just paste the reference ID which I had copied earlier from packages, that was of busybox. Okay. It is saying that that package is depending on busybox. Okay. Now, what is the reference? What is the thing that we are learning from here? Okay. So it is just like A and B hierarchy. Okay, so A depends on B. But if B is having any vulnerability, then it will directly affect A. So that is the thing that we are learning over here. So depend on the says that if something goes wrong with package B, then it will have an indirect effect on package A. Okay. So yeah, that was all about XPDX, where we learned about how you can do the visualization for an image that is Alpine 3.15. Now let us do the same. Okay, let me clear the screen. Now let us perform the same with Cyclone DX. So what you have to do is just copy this entire command once again, and instead of format, just type Cyclone DX. So I'll just paste it over here, and here I'll just remove SPDX-JSON, and here I'll write Cyclone DX. Just make sure the spelling is correct. Cyclone DX. Output is in result JSON, and the image will be again Alpine 3.15. Now what it will do, it will again write the report, and things will be available to us. Now how do we visualize it? But before even that, I'll just do a cat, and here again it is difficult for us to read this JSON. Again, we'll need a visualizer. I'll open a tab again. I'll write Cyclone DX viewer, and here we have a tool created by Sunshine, which is a SBOM visualization. All you have to do is just choose the file, click on result.json, and here you can see the file is getting loaded. Okay. And here you can see all the summary is present over here. Okay. Now, a cyclone.dx is dependent on Trivy, and this is used for vulnerability scanning. Okay. Here it is showing the main component, type container, name of the image. Okay. And then it is maintained by acquired security. It is showing the as the SHA-1 hash. Okay. Here we are getting the serial number. Okay. And the component that is used. So component type is application component. Okay. Now, if I scroll to the bottom, here you can see the component chart. Okay. It is telling us the base layers that it has scans. Now, if I scroll all the way to the bottom, here we are getting the complete details. Now, what is the component? What is the depth? What are the things that it is dependent on? Okay, and it is the dependency of which image? Okay. Now, again, it is showing us the license also. So these are all the details that we are getting. Now, again, in terms of vulnerability, if you want to just scan only the things which are of critical, so just select this filter and click on apply setting. It will only show us the images, the base layers that are of critical severity. Okay. So that is how we use Sunshine SBOM viewer. Okay. And now if you want to report this, okay, you can just click on print and things will be visible to you. Okay. And now, yeah. So if I go back again, I'll just choose the file. Okay. So there are different ways to print it. You can just go and create an Excel, you can create a CSV and just share it to the people who will do the patching thing, right? So in this video, we learned about how you can generate an report using SBOM, using Trivy. We learned about Cyclone DX and SPDX, right? So yeah, that was all, and I will see you in the next one. Alright, welcome back. Till now, we have been scanning the images manually by running the command privy image followed by the image name. But what if this task is something that you have to perform on a regular basis and you are being asked to submit the report, right? So at that time, a real DevSecOps person will definitely try to do some automation. And here today we are going to create one automation that will generate the report for us. The only input that we will require is to enter the image name. That's it. Okay. So today we are going to do that automation that will make our life easy. Okay. Without further ado, let's get started. So whatever we have learned so far, we are going to add it in this single video so that you will have a clarity what we have been doing so far. Okay. And at the end, there will be a take home assignment that I would like to give it to you so that you can also explore and you can also gather some hands-on experience on the shell scripting and the things that we have learned so far. All right. So without further ado, let's get started. So what is the basic thing that we have been doing so far? So let's say Trivy image followed by the image name. So let's say Python colon 3.10 hyphen slime. So this is the image that we have been scanning so far. Okay. So Trivy runs the automation scanning and the report is generated in front of us, right? But what if I want to rerun this again and again, right? I have to fire this commands once again. But what if I just want to provide the image name and it should do the job and there is a text file that has been created? That is something that we are going to do. So for that, what I'm going to do, let me just create a folder name shell. Okay. And I'll go inside that folder. Okay. All right. Let me just do it a little bit zoom. Okay, cool. Now the first thing that we are going to do is let us create a shell script for it. Okay. So I'll just create a script. So let us write a name for the script. So I'll write trivy-scan.sh. Okay. Now, what would be the first thing that you would write in the initial state, right? So that would be the shebang, the hash exclamation /bin/bash. Okay, so we have written the shebang. Now, what is the command that we are trying to fire? So basically, this is Trivy image followed by the image name. So that can be anything. So let me just write it as a variable image. Okay, and here let us write the variable. So image is equals to, and here I'll write Python colon 3.10 hyphen slime. So this would be the image name. Okay, so image here is a variable that we are passing right now. Okay, now what else do we need? Now see, since it is a report and we are trying to store it in a place, so let us create a directory where it will store the where it will store all the images, right? So The next thing would be to store the report. So the report would be stored in a repository. So here we'll write repo, and that repo would be Trivy reports. Okay. Now let us make that repo. So how do we make a repo? So we make a repo by using the command mkdir-p and followed by the repo name. So let me write a dollar and here I'll just paste it as is. So the repo is created and then it will run the command trivy image. Okay. But I just want to see only the issues that are created under the severity high and critical. So let us change the command. So trivy image, and here I'll write hyphen severity. Okay, followed by I just want to see high and critical. Okay, and then the format. What should be the format? So the format should be table. Okay, and then followed by the image name. Now, when I run this command, what will happen? It will show the output on the console, but I want to store it in a place. But what is the place? So it should get stored into the repository that we are creating. So I'll just write hash over here. So under repository, now what should be the name of the file? So it should be Trivy report, and I want the timestamp too, right? So for that, I'll just add a variable for timestamp. So here I'll just write 1 second Trivy report followed by the timestamp. So that is date dot txt. So this would be the format. I'll go up and here I'll define date variable, and that would be basically a combination, okay, of basically you can write here as date, okay, plus year hyphen percentage m hyphen percent d, and here we want r and minute to when it was scanned. Okay, I think we are good with this. So what it will do, it will read the image. We have a repository that is created. So the first thing that we are going to do is we are going to create the repository. So this section basically creates the repo for EV reports, and here scanning Trivy image, and here we can write some athu command so that we will have a clarity what is going behind the back. So scanning image followed by the image, and here if you want you can write the timestamp too. On date. Okay, and once this is done, you can write one echo command to mention that the scanning is completed. Okay, so this is the basic structure that we would be following. So let me just do escape colon wq and just give it the permission chmod plus x followed by Trivy scan, and let me just run the Trivy scan. Okay, now what it does, basically it will run the scan. I think there is an issue with the date format that we have added, so we have to fix it. Okay, no worries, we'll fix it. All right, so it is saying the scan is completed. Okay, when I do ll, folder is created. I'll just go inside that folder. So cd Trivy reports, and when I do long list, here a Trivy report is present. All right, so let me just do a cat and let us see what is the output. see here we have the output that is present in front of us. But right now the thing is, the format is not correct. Okay, here the date column should be added. That is something that we are going to fix now. All right, so let me just go back, and here I'll just open the Trivy scan image, Trivy scan shell script, and here, okay, the first thing that we need to do is to get rid of the space. Secondly, this should be here, okay, and there shouldn't be a colon here. Okay, now I think things will work in our favor. Okay, let me just rerun the scan once again. Okay, let us see now. All right, you can see the date timestamp is visible now. Okay, now let us wait for the scan to complete it, and let us see whether the expected and the desired result that we were looking for is actually present or not. Okay, and apart from this, in the repository I have documented each and every step, okay, so that it would be clear for you to what is actually going behind the back. Okay, the scanning is completed. Now let us do long list, and I'll go to Trivy reports. And here you can see the Trivy report is present with the timestamp and with the date. So it is easier for us to identify when the scan was done. But again, the thing is, there is one more thing that we can do over here, right? Now, since it is a shell script, it has made our life easy. Okay. What we can do, we can ask the user to write the name of image, correct? So what I'll do, I'll just write vim trivy scan.sh, and here instead of hard coding the value, let us read it from the user. Okay, so what I'll do, take user input for image name. Okay, and here we are going to write a command like a read -p, enter image name for scanning. Okay, and whatever would be the result that will get stored in this image. Okay, and let me just get rid of this. So what we have done, we have added this read mode over here so that the user will be prompted for the image, and then he will be entering the image. Next thing what will be happening, here we have initialized the variable. So variable initialize. Okay, and then the Trivy report will store in this repository, and then we have defined the date. Okay, now the last thing that I want to do would be the echo statement, which will give us a clarity that the report scanning is completed and it's stored in the specific location. The report is stored in, so it is stored here. Okay, done. Skip :wq, and now let me rerun the command once again. tvscan.sh, and here I'll write Python :3.10 hyphens line. Again, it will run the scan, and now it will show us the echo command to the report is stored in this specific location, and we can just directly do a cat over here so that we can directly read the report from our root location. And here you can see the output is present. How good it is, right? Now, that was all about this video. In the coming videos, what you can do, you can just take us so now assignment for you, what you can do right now is you can just rewrite this shell script, modify it accordingly. You can try to do SBOM scanning, Cyclone DX scanning. Okay, even if you want to present the report into HTML format, how you can do it, you can just write the logic over here. So what would be the thing that you can do, right? See, there are multiple things, multiple possibilities that you can perform when it comes to shell script and with Trivy. Okay, now if you want to get the result in HTML template, so just change this line and provide the HTML template over here, right? It will generate the HTML template for you. There are many things that you can do, right? So assignment for you is, now we have generated the report for txt, you have to generate an HTML report for this one, right? And you already know how to do it, right? Yeah, that was all. And before you leave, just want to tell you one more thing, that everything that we have done so far is been documented in this sub repository number 8. Okay, you can just go through it. And also the assignment that you are trying to do is just I want to you to try it first, and if you face some issue, just refer the second file, that is html scan.sh. Okay, here you'll find the entire shell script, and the way you want to run it, everything is been documented over here, right? And if you want to go through the shell script that we created right now, it is also pushed over here so that you can just take a reference and that it would be easier for you, right? So yeah, that was all, and I will see you in the next lecture. Thank you. All right, welcome back. Today we are going to discuss about something called Trivy Server mode, a centralized enterprise scanning system. Okay, now before even we move down to Trivy Server mode, let us first understand what was the actual problem with Trivy local system, right? Because till now we have been doing multiple scan, we have been fixing things, but what is the root problem? Why we are moving to Trivy Server? Okay, so let us discuss what are the problem with local Trivy XCL. Okay, so when you run local Trivy commands, what happens? So each machine downloads the vulnerability DB. Each pipeline updates the DB separately. Now consider you are not the individual person working in a company. There are hundreds of developers who are working on it, right? So in that case, this is applicable where each machine download the vulnerability DB. Each pipeline updates the database separately. The scan results varies upon timing because you update it on Monday, someone updated on Wednesday. So based on that, the values may differ. The database will update accordingly, right? And due to that thing, the network usage will increase and the CI/CD pipeline will slow down. Okay, so when local scanning is good, local scanning works great for individuals, but it is not a good option to go with local scanning when you're working with enterprise, when there are multiple people working on scanning, right? So that's the problem that has been solved by Trivy server mode. Now, what is Trivy server mode? So Trivy server mode, basically it is a centralized scanning architecture. So instead of the client downloading the DB, each client scanning the file independently, you have one Trivy server, okay, with multiple Trivy clients, a shared central updated database. So if you want to just visualize it, this is the image that you can take a reference for. So there will be a server, okay, which would be maintained by Trivy. There will be a centralized DB that would be there, okay. All we have to do is we will serve here as a client. We will run the Trivy commands. The data will be a centralized place where it will be coming from. And yeah, every data will pass through this Trivy server. So you will be passing the scan request. The scan request will process through this Trivy server, and the database, basically it will get updated based on the request and you will get the reports. See, as an end user, as a local Trivy scanner, the output will remain the same. Here, the only thing that differs is there will be a centralized Trivy server and the centralized DB store, right? Instead of individual having the individual having the database structure, here it will be in a centralized way. So why enterprise prefer server mode? So first option is the first and most important option here is centralized DB management. Now, if you go through this diagram, we are heavily focusing on centralized DB structure and a Trivy server, right? So when we go to enterprise, so why we prefer server mode? Basically, there is centralization of DB management. The DB update happens only once instead of multiple times. Now, when you run it locally, every time the DB will get updated and you will have a different definition, someone else will have different definition. But when we go with server mode, you will have a centralized DB manner. Okay, you will be having a DB update that will be happening only once. There will be same CVE data for everyone and the result will be predictable. Second, there will be faster CI/CD pipeline, so no DB in every job. There will be lower requirement of network usage, and the feedback would be faster. And the most important is consistent security policy. So everyone will have same severity rules, same scanning logic, and same output will be there everywhere. So that is why enterprise prefers server mode. So when we should use server mode? When you have multiple CI pipelines, when you want consistent result, when you operate in a regulated environments and you care about the auditability and you want faster builds. And when not to consider server mode, so basically when you are a solo developer, when you have small team and you have local, if when you want to do local experiments and when you are learning Trivy, at that time you should not consider server mode. Okay, but when it comes to enterprise, when multiple people are gathered, at that time you should consider Trivy server mode. Okay, so that was about the theory part. Let us directly jump to the practical and see how does Trivy server actually works. So let me go to my terminal, and here I'll show you how does Trivy Server works. Okay. So the first thing is you don't even have to install anything. All you have to do is just write Trivy Server. It will launch the server for you, and it is saying that it is listening on port number 4954. Let me go to my web browser and I'll type http colon slash slash 0.0.0.0 colon, the port number is 4954. Here we are getting 404 not found. We don't even have to worry because TV does not even support web UI. It is just for checking because at the root page there is nothing that Trevi hosts. That's why we are getting 404 not found. But to validate whether the server is up and running, just write / and health z, and it is saying okay, meaning it is up and running. Now what we have to do is, let me open one more terminal over here. Okay, new window, and I want it to be side by side, so let me just merge it. Okay, and yep, here would be the actual place where we would be running the commands, and side by side you can see the output for the TV server. Let me just minimize it somehow. It is showing that it is listening on port number 4954. Okay. Now, how do we run a Trivy scan usually? So we write Trivy image followed by the image name. So let us take the same example, Python colon 3.10 hyphen /. This image we have been using so far, but the only change this time would be to add the server flag. Okay, and everything will be done in a centralized manner. So hyphen server and followed by the server address. Now, what is the server address? It will be http colon / followed by localhost. So 0.0.0.0 colon the port number, and port number is 4954. Enter. Okay. Now it will run the scan, and parallelly we will see the behavior change at the left hand side. So see, it uses a centralized version. Okay, the DB was updated of the tree. The DB for the centralized TV servers was updated, and we got the result output. Okay, so that is how you make use of Trivy server. Now here I was the only user who was using it. Okay, now consider there are multiple people using the same Trivy server. At that time, it will only refer the DB that is maintained by this Trivy server, right? So there will be only one source proof of reference. Now if I want to scan one more result, okay, let me just clear the screen and let me just do a little bit zoom so it is visible for you. I'll write Trivy image, let's say Ubuntu latest hyphen server, and the server would be http colon / 0.0.0.0 followed by the port number 4954. Okay, and enter. It will again run a scan, but this time instead of running the DB scan from my local, it will refer the DB of the Trivy server, right? So that was the beauty of Trivy server. Now, when you are working in enterprise, multiple people are working on it. At that time, Trivy server will come into the picture, and this will literally help in fastening your Trivy security scans, right? So yeah, that was all, and I will see you in the next one. Thank you very much, and keep learning. Till now, we have been learning a lot about Trivy. We saw what actually Trivy is. We gone through intermediate topic. We even saw how does a Trivy server works, right? In this video, we are going to gather all the things that we have learned so far. And today we are going to work on one of the requirement where you have been asked to find out the SBOM report, the HTML report for a provided image. Okay. So this would be a set of automation that we would be doing. All right. So yeah, let's get started. So for this automation, whatever we are going to do, I have already documented everything under sub repository number 9. You can just refer this repo and then you can proceed along with it. Each and every detail is provided over here. However, I will be telling you everything, whatever you need to get started with this automation. Okay. So let me first create the basic infra for you to perform this operation from the very much scratch, and whatever else is required, we are going to do on the fly. All right. So let's get started with it. So the first thing that we would be needing is an EC2 instance. So let me go to EC2, and here I'll launch one instance. I'll name it as Trivy requirement. Okay. The quick start, from quick start, we are going to select the Ubuntu as an operating system. I'll scroll down and here I'll select the instance type, again a free tier one, but this time I'm going to select M7i Flex Large with 8 GB of memory. Okay. And this time I'm going to create a new key pair and I'll just write uh, Trivy demo. Okay. And let me just create the key pair. Now it will download a key pair for me so that I can do the SSH activity. And here I'll just allow the HTTP and HTTPS traffic. Okay. And here in the configure storage option, I'll just mark it as 20. Okay. Now everything looks fine to me, and then I'll directly click on launch instance. Now here it is launching the instance, and meantime, what are the things that are prerequisite for this project? I'll go back to my repository and here I'll just show you what are the prerequisite. That is Jenkins. Okay. Second is Docker and third is Trivy. These are the three things that are required for us to do the automation. All right. So we are going to do the installation from very much scratch. So it would be easier for us to. I'll just go here and let me just connect it with my terminal. So I'll just search for item. That is the terminal that I'm using. Let me just do a little bit of zoom so that it is visible for you. And I'll go back and here I'll go on connect. I'll copy the example SSH command and I'll go to the place where the SSH key is being downloaded and then I'll perform the SSH activity. Okay. 1 second. See, I'm getting this warning. Why? Because the permissions are too open. So for that, what permission should I give? So basically chmod, okay, 400 for the provided key. Okay. And here the key we are referring is tbdemopan. Now again, I'm going to fire the same command and this time it should work properly. Okay. Now we are inside the VM. Okay. Inside the instance, I must say. And let me just clear it. And now let us start with the installation process. So the first thing that we would be installing is Jenkins. So Jenkins installation on Ubuntu. I'm going to refer the same document that we have been referring so far. I always recommend you to go through the official documentation. On the left hand side, select Linux and here we are going to select the flavor, that is Debian Ubuntu. Scroll down and here we are going to install the first prerequisite thing. In order to install Jenkins, the first thing that you need is Java runtime environment. So I'm going to install the same. And let us wait for some time so that it will install Java runtime environment. It will refresh the package sources, and then things will be good to get good for us to install Jenkins. Okay. So yeah. Now let me go back and here once everything is done, I will install the long-term support project from Jenkins. And let me wait for some time so that it will do the installation completely for us. Okay, so the base is done. Now let me paste the long-term support command and this will install Jenkins in my system. Okay, and meantime, Jenkins run on port number 8080. So we need to expose it with the security group. So I'll go back to my AWS instance. I'll go back to instance and here I need to enable the security group. So let me just go to instance, scroll down, go to security and under security groups, I need to edit the inbound rule. And here I need to allow the port number 8080. So here I will be adding a rule and here this would be a custom TCP. I'll just add port number 8080 where the traffic can come from anywhere and I'll just take the rule. Okay, my rules are defined now and now I'll just go back to instances. Okay, and here in the instance section, I will need the public IP so that I can access my Jenkins. So HTTP :/ followed by the public IP followed by the port number 8080. Okay. Now here there will be a login form which will ask us for a password, a secret password that is required for the initial setup of Jenkins. I'll go here and run a cat. So I'll just paste it and when I press enter, this is the value that I am looking for. And I'll just add it over here. And meantime, it is installing the suggested plugin. I will go through the further installation step with Docker and Trivy. Okay. So let me click here and here it will start the initial setup. Okay. Okay. Now the next thing is I want to install Docker. So Docker install on Ubuntu, Docker install on Ubuntu. I'll go over here scroll down, and here I will find a package. So here, these are the command that are used to remove the conflicting packages. I'll go over here. I'll go with the proper documentation this time, and I'll just paste it over here. Okay, and this remove the unnecessary packages which are not required. Now I will copy the Docker command which is used for installation of Docker. Now once everything is done, Docker will be installed in my system. So system ctl status Docker, and here it is saying docker.service could not be found. Let me just check what is the issue. So I'll just do an update, sudo apt update. Now again I will fire the same command for installing Docker. Okay. Okay, now here you can see the Docker system, the Docker service is up and running. Okay, now I'll go back to my Linux screen, and here you can see the setup wizard is present. I'll just update it with my username, password, again confirming the same password, full name, email address, save and continue. And yeah, we are good with Jenkins setup. Okay, now I'll click on start Jenkins. And here Docker is also installed. The only thing which is pending right now is Trivy. So I'll just write Trivy install on Ubuntu. I'll go with the official documentation for it. And here I'll scroll down since we want to install it on Debian Ubuntu. I'll just copy the command and this will install Trivy in my system. Okay. Okay. Let me confirm Trivy -" version. And Trivy is installed too. All right. Now the base, whatever was required for us to run the project is ready. Let me explain you what we are going to do today. So for this, I'll go to my Jenkins file, and here is the place where I will tell you what are the things that are currently going to do. See, basically we are going to build one artifact by a basic application file, and it is a Python based application that we would be scanning. Okay. This is a very basic application that runs on port number 5000. Okay. And just print Trivy plus Jenkins DevSecOps demo as a output. Okay. But the main thing for us to perform this operation is to find out the artifact that we are looking for. Now, what sort of artifact it will give us? See, first of all, it will going to create one directory, and then it is going to perform a Trivy scan that will give us the format output in JSON. Second, it will give us the output in HTML report. And thirdly, for the same image, it will generate an SBOM file. Okay. These are the three things that we are going to generate in a single automation, right? So yeah, let's get started and set up the initial thing, whatever is required. So I'll go to my Jenkins dashboard. I'll go on, click on create new item, and let me just give this job a new name. So the name would be Trivy report automation, and this would be a pipeline based automation that we would be doing. And here I'll copy the URL that is required for us to add it in this specific one. I'll scroll down, and here we are directly going and jumping to the definition, and this would be a definition that will be described in the source code manager. And here we need to provide the source code manager. We are using Git, that's why we selected Git, and it is expecting for one input, that is the repository URL. Now we have added the repository URL, and then you need to confirm the branch. Here the branch is main, and then what is the script part? Now see, if you go over here, now since the file is stored on the sub repository number 9, okay, therefore I will be changing the path. But if you are creating your own, in that case, this won't be valid. Why? Because see, this is a monolithic repository that I have created, but in your case, it will be at the root, right? So that would be the only difference. But if you are following the same monolithic structure, it would be the same for you too. So let me click on save. And now let me just click on build now. Now it started the build. Okay, we got the failure. Okay, let us scroll up. What has happened? Let us check. So see, the initial thing that is required for Jenkins to do is the pull. It already performed the pull. Now the next thing that it is saying is fetching changes from remote Git repository, which is correct. Okay. Now what is the actual issue over here is, if I scroll down, it is saying permission denied while connected in Docker daemon, meaning the user doesn't have the permission to for doc. So basically, the user doesn't have the permission, right? So that is something that we are going to do. Let me go back, and here I'll run command user mod hyphen append user to the group. Okay, and in the Docker group, add Jenkins system ctl restart Jenkins. And same we are going to do with Docker too. And let me restart Docker too. Okay, when I go back, I will just have to refresh it. And this time it will ask me to log in again because we performed the system restart. And let me just log in. Okay. And now let me trigger the build once again and let us see whether we are going to face the same issue again or not. I'll hover over here so that I can directly run a build. And I'll just click on build now. The build is scheduled. I'll go over here. Okay, this time it is working fine. There is no issue from Docker's end because we have given the necessary permission that is required for it to run. Okay, now it is running the Trivy command too. Now things are very good for us because it is generating the artifact for us. And this was the actual required output from this automation. If I show you the console output, everything is running fine as it was supposed to. Now, if I go to the second build, these are the three artifacts that we were looking. Okay, if I click on view, you can see the SBOM output. This SBOM output you can download and give it to the people for security purpose. This is the HTML report that we were looking for. Okay, if you want to download it, you can just directly click here and download the file. Okay, this is the HTML report that we were looking for. Okay, so in a single click, we have generated three artifacts for the same image, right? In this, so basically the purpose of this automation to generate was to generate three artifacts from a given image, and we did the same. We generated a SBOM file, we generated an HTML report, we generated an JSON report, right? So yeah, that was all in this report, and whatever you need is already been documented over here. The Jenkins file, the readme file, the requirement.txt, the Docker file, everything is present over here, right? So yeah, I will see you in the next one where we are going to do one more automation where we are going to consider that there are multiple images that you want to scan at a single time and want to generate the repo, right? So how to do that? So that is something that we are going to see next. So yeah, that was all, and I will see you in the next one. So here you can see all the vulnerabilities are present as is. So this was the exact output that we were expecting. It has been a very long journey with Trivy, and today it marks the conclusion of the series. Today, we are going to work on the final automation where you will be scanning multiple images and there will be reports for each one of them. This report, you can share it to the audit team and then they can perform the audits, right? So yeah, in this video, let us work on an automation that will expect multiple images and input, and there we will create individual HTML file just in one command, right? So let's get started with it. So for this specific demonstration, you have to refer sub repository number 10. Okay, and here all the files are present. Let me take you through the repository. Okay, so here you have the basically documentation of all the things that are currently present. Here you will find the project structure. The main file that we would be referring to, which is the target of today's video, is trivy image scan.sh file, okay, which will perform the actual scanning. This is written in shell script so that your automation will work smooth. Okay. Now, second is scan image.txt, the place where you can list multiple Docker images. Not just for the sake of this demonstration purpose, you can literally place any Docker image that you want to scan and get the report for. Third, there is an html.tpl, basically the template that we would be using, right? If you remember in earlier videos, we were using one template, right? And this is the same template that we are using in this specific one. And now we are also considering the case that even if the template does not exist, then the script should handle to download this script template and then execute it accordingly, right? And then the reports will be stored by the name image name.html. So this is something that it is supposed to do. Now here there are few prerequisites. If you want, basically you will need Docker, Trivy, wget, and any of the OS. I will be working on macOS. The same can be performed in Linux also, right? So these are all the installation command, and I believe this is not even required in your case because you have been doing Trivy along with me. So like this is already installed in your system. But someone who is directly coming to this video, you can just refer this documentation to install Trivy, right? And here you will find all the scan image stacks and the way to execute this script, right? So let's not go into theory. Let us perform the practical and let me show you what we have handy. So this is the shell script that I was talking about. Okay. Now here, what exactly it is happening? We define the shell script. Okay, Shubham, and here we define the input file, that is scanimage.txt. Now if I go to scanimage.txt, here there are 9 to 10 images that we will scan in this specific demonstration. And then if I go back, here we are checking the prerequisite. The first thing it is checking is whether do you have Privy installed or wget installed. Once it is installed, then we can proceed forward. And then here we are checking the input file. Okay, so basically it is going to check whether the scan image.txt file is present or not. If not present, it will throw an error. Now next is we are downloading the html.tpl template. Now first again, if it will check whether the template is present or not. If it is not present, then we are going to download it using the command wget, and that is the exact reason why you need the wget in the prerequisite. Okay, then again it goes for the it will go through the iteration where it will scan each and every line as an image and will generate the report for us. And which command we are exactly using here? It is trivy image, and here we are only scanning the issues that have severity high and critical, and then it will be formatted into a template, that is html.tpl, and those output will be stored in the output file. Okay, and the output file logic is already be defined over here, so it is easier for us to understand how does the output file will look like. And then once everything is done, it will say report generated successfully and all scans are completed successfully. Now let us try the execution for the same. Let me open the terminal. Okay, and now let me just execute the screen. So I am in sub repository number 10, and here I need to execute trivy image scan.sh. Now it will scan each and everything, and here if I go to the report section, it will generate it. Okay, 1 second. I think it is already present since I was preparing it. So let me just delete entire thing. Okay, so I have removed all the earlier reports that were present, and now let us re-execute the shell script. Okay, now if you just keep an eye over report section, you will find the images, the HTML reports are getting generated automatically without even us doing any manual thing repetitively. So all we should be worrying about is just to update the scan image.txt. You just have to paste all the images that you want to generate a report for, and the automation will generate it for you automatically. So that's the beauty of this automation. And let me just open any one of the report just to show you how does it looks like. Okay, so if I go to Alpine, okay, if I just go over here, so if I just go over here and I'll just want to view it, so just let me type open followed by the HTML report that we want to open. So it is report slash Alpine, and here you can see there are no vulnerabilities present in Alpine image. Let me open some another image. So let me open another report. So report slash, this time let me open
node file. So here you can see all the vulnerabilities are present as is. So this was the exact output that we were expecting, which was giving us only the issues that were of severity high and critical. So yeah, that was all about this automation where we scan multiple images in one go. That was all, and I will see you in the next one. Thank you very much and keep learning. So in this video, you not just only learn about Trivy, you learn the flow of the vulnerabilities that flows from code to image to production. You also not only just learned about scanning images, we actually saw how does CVE works, what CVE is, what are SBOMs, right? And apart from that, we just not only executed commands, we actually tried to automate it, right? And don't worry, you will get all the resources that we have been using in this video so far. Everything will be pinned in the description section, so you will not left out. And also I will also pin the GitHub repository that we have been using so far, so that you have everything under one hood. And yeah, that was all from my side. I hope you enjoyed the journey with Trivy with me. Okay, share this video to the people who would love to explore Trivy, right? And also, before we wrap up, just wanted to tell you one more thing. Security done later is expensive, but security done in the early stage is what we call DevSecOps. So yeah, that was all from my side. Thank you and keep learning.